Welcome, everybody. This is the 25th of May, and you're watching or participating in the Dallas Personal Robotics Group Robot Builders Night Virtual. And we are going to do the usual thing we do pretty much each Tuesday night, and just go around the table and talk about our different projects and ask questions and offer advice or solutions or ridiculous, silly things. My name is Carl. I'm the current president of the club, and I more or less facilitate as we go around the table. Having said that, we have a kind of a lineup started here, so let's just take it off. Ted, sounds like you've been rebuilding your robot on a weekly basis. That's pretty impressive.
Yeah, so I'm excited about my new configuration. I'll show you some pictures here. Let's see. I want to do probably screen. There we go. Share. All right. So what I've got going here is I 3D printed these brackets in Rainbow PLA, and the point of them is to allow the sides where the motors and wheels are to be bolted onto the top plate. And that's working out great so far. I think eventually I'll reprint them in TPU, so it's a little bit flexible and stronger, but so far it's been plenty sturdy enough. So this is the top. Let's see, the wheels are front to back are about 8 inches and side to side is 16. So it's about twice as wide as it is long front to back. And let's see, I got a little video to show you here. Yeah, there's plenty of ground clearance now, about 2.5 inches near the wheels here, and then it goes up to 5 inches in the center. So you can see it has no trouble getting over grass, and it turns just fine.
It's a fast little puppy.
Yeah. It can also go slow. The gear ratio is pretty good for doing this, and you know that's a 2x6 I think on a box, and it just goes right over it, and you can go over my downspout pipe there.
Poor downspout pipe.
Yeah. The only problem is it's got enough torque on the wheels that if I jam the throttle, it'll flip over upside down. So I might need to build a wheelie bar or something.
I'm assuming it doesn't fulfill David Anderson's sort of curb requirement, but it still looks pretty cool.
No, and I have another video here where I'm going through some tall grass, and then it goes up to the curb on the sidewalk, and it's right there. It's about, I don't know, like 4 or 5 inches going up to the sidewalk there, and it just isn't able to do it without flipping over.
Little too much.
Yep, just a little too much. Anyway, yeah, I finally got it rebuilt. This time I did it semi-permanent so that everything's attached to it and not falling off and wiggling around, and it's working a lot better. So I'm quite happy with it now.
And
so
Ted,
I think, yeah.
Sorry to interrupt. I was just going to ask a quick question. I think you discussed this before, but the reason you've made it wider than longer was for turning radius, I think, wasn't it?
Yeah, it turns better. There's less skidding going on. You know, they call it skid steer because it skids in order to steer, but with the wheels being wider, it doesn't skid as much.
But if it was square, it might be less likely to flip, I think.
Yeah, it's less likely to flip. The other reason I put the wheels close together is because if we go back to that other video where the downspout was, it would get stuck going over the water rain spout there.
Oh, you mean like halfway between the wheels?
Yeah, it would get, what do you call that? high centered in the
Yeah.
middle there. So if I have the wheels closer together, they're not doing that.
Yeah, if you've got a round profile on your wheels, I like your idea of actually having the motors at an angle.
Yep.
Yeah, so the motors are angled up, so that gives me more clearance in here. And then, this was where the distance between the wheels were. It would get stuck on things going over. At one point, there was a kind of a stick it was going over, and it got stuck on that. So I thought, well, less room back to back, it's less things to get high centered on.
And if you had a bar on the back with the wheel, that'll take care of the flipping. So I do
Yeah.
like that idea.
Yeah, a little wheelie bar.
I wonder, I haven't messed around with these that much. I've just been playing with flat on indoor so far, but I wonder if you made the wheelbase longer, more square or whatever, but then to take care of the high center problem, I wonder if it could work if you had like just drone roller wheels. So something that could rotate
You
as
make
long as
it
there's
like
enough friction on the other wheels.
Yeah, eventually what you end up with is a tank, right?
Right. One thing you would need to have two hinges effectively on the three plates. In other words, have it sort of like a caterpillar type thing.
No, I'm not suggesting that. I'm saying
Well, you're saying put wheels in the center
I'm
effectively.
saying
So yeah.
4 drive wheels, but then just dummy with not like a caster, but something that spins freely on its own, so that if it gets hung up on something, it's not going to get stuck on the metal bar. It'll have a rotating.
Yeah, actually, I hadn't thought that's a good idea. So it's more like a 6-wheel robot with only 4 drive wheels.
6 or 8, yeah, but then the middle ones would be up high, so they're only engaged if you happen to get stuck on some obstacle like your gutter.
Oh dang! Now I've had more ideas.
Excellent. I love to stir the pot.
But the other thought I had was, with robots you can make 2-wheel balancing robots, so there's no reason once I get an IMU on there, I can actually sense the angle and compensate by stopping the wheels or turning them back to keep it from tipping over.
Very nice.
So yeah, my next plan is to start putting sensors on. So yeah, I think I'll put an IMU on it and start getting a little bit of autonomous driving now.
Did you already tell us what you're going to use for a controller or a combination of things to control everything?
Right. So in my previous bots, I've used a teensy microcontroller with a BNO 055. And I plan to add a GPS to that. Yeah.
Then you're going to have some PWM, some H-bridge gadget that the teensy is going to control, I suppose.
Well, so I'm just using
you're gonna need control 4 motors, right? So are they somehow
right? So what I've got is a RoboClaw
okay
driver, and so that takes PWM. So I'll just use PWM out, or I think it also has an interface for a microcontroller, a serial interface. So I'll do some combination of that. I might, but the PWM is fairly easy, and that way I can have a use the same interfaces for my radio control.
And the RoboClaw drives 2 or 4 motors?
It drives 2. So what I'm going to do is
you're going to run them in pairs?
Each side is tied to one of the drivers. Okay. Oh, David's here. So David, I just showed my running robot, so I'm hoping to get my gold star from you.
What about encoders? Do you have any anything like that on that, or will you? Or are you going to go just blind?
No, I am using encoders. The motors I have built-in encoders.
So what type of motor is it? Is it a 6 volt, 12 volt, 3 volt?
It's a 12 volt Let's see. I think it's 400 RPM is the gear ratio.
Are they yellow jackets?
Yeah, they're yellow jacket.
Those are nice solid motors.
Yeah, it seems to be. Nice beefy output shaft. So I just have the wheels tied direct or mounted directly on the output shaft.
And I think they're actually, I can't remember about the yellow jackets, but I think that they're ball bearing rather than plain bronze.
They are ball bearing, yes.
Yeah.
That's very nice. You're making
So-
good progress.
Yeah, I have a question for the group. Any recommendations on GPS units?
GPS or GPS RTK?
No, just GPS.
Well,
I know-
I'm using a Raspberry Pi, and if you end up going with a Pi, I've been using the Pimoroni one, which is just it's like a 1010. I can't remember the actual model number. I'll look it up, but it's a really simple plug and play GPS, tiny little thing. It's the same size as these little breakout gardens. If you go to Pimoroni and look up breakout garden, they've got one called I'll take a look for it. But it was dead simple. It's in Python, by the way. So for the Python.
Okay. Yeah, I was kind of looking for something with an external antenna mount, so I heard putting the antenna on a ground plane helps a lot. Just a small plate of steel.
I totally agree that having an antenna gives you an advantage. But to be fair, this little PA, it's called a PA1010D, and it's actually got a little onboard antenna on the board itself. And I'm in New Zealand, and if I take my robot out onto my front deck, I get like 9 satellites almost immediately. So as long as it's got open air, it seems to work really well. But yeah, the antenna would give you better performance, certainly.
So on that GPS, do they have good examples software wise, or how hard was it to interface?
It was about the easiest thing I've ever done, actually. It's just it's a single Python library, and the example file just pings the thing and gives you back the entire array of data that comes off of the device.
Is it serial UART?
No, this is I2C.
Oh, okay.
Yeah. And so, like I said, it does everything for you. All I got to do is just put the thing in a loop and ask for data, and it just sends me all the GPS data without, it's brain dead simple, which is one of the reasons why I kind of like it, is that it's I2C, and I don't have to think about it. I just get data. So it's a lot easier than a lot of the other ones. So,
Okay.
yeah, but it doesn't have an external antenna that you can plug in. It's just got the little onboard ceramic box antenna.
So it doesn't have an option to plug it external if you wanted to?
No, it doesn't. The Adafruit sells a bunch of them that do have the little antenna connector. This one doesn't. It has an onboard only.
Yeah.
Now, I haven't messed with them, but one thing that's in the back of my mind is because I spent so many years working at Nokia mobile phones, and that is that if you use a mobile phone that has a GPS device, a lot of those will use so-called AGPS. So even without GPS RTK, the AGPS uses a combination of the signal from the satellites and knowledge of the adjacent cell towers. So it can give you a pretty accurate, that's how a lot of our watches and phones give a pretty accurate placing even without RTK. So one of the things that's been in the back of my mind is to get one of these cheap little $50 Android phones, export the high precision GPS signal from that, and just get it into the robot via BLE or UART or USB on the go, whatever. So that's another consideration, because you can get a cheap Android phone for nothing these days. And in my way of thinking, if you have even a $50 or $100 Android phone, that gives you a lot of other capabilities that you're not going to get with a $60 GPS module.
Carl, what's the update rate for those?
I don't know. I haven't looked really. There's so many ways to get the data out, but I think it must. I'm betting that it depends on the phone platform API. So I think that's going to vary by chipset and manufacturer and mode that you select. So for a couple startups ago, I did a demo, and it was using one of these cross-platform phone gap or Cordova-based things. So basically, you would write JavaScript, and it would compile down and run in an embedded browser on the phone. And that application that I wrote on the Android phone was able to extract the GPS data. So you can even run a web app and export the GPS data. But that was only I think I had that grabbing it at like 1 or 2 hertz for that purpose of the day.
Yeah, I would think you'd want at least 10 hertz. Probably more would be nice.
But I would be surprised if there was heavy restrictions by that. I think I remember for sure that there was a couple different modes you could throw it in, because like in mobile phones, they're very considerate of battery draw, and whenever you have the faster update rates and sampling, it tends to consume a lot more current. So phone apps tend to be really miserly on the battery, but there's also ways where you can coerce the platform to do things a little faster than it normally would, right? If you're aware of it. So I'm just putting that out as a out of the box thinking example, right? Versus the Adafruit or Pimoroni or some standard thing we might use.
Yeah, I have an input too, Ted. One that I would recommend, first of all, I would say make sure it's a U block. Okay, get a U block.
Okay, yeah.
That's the first thing. Now the one I'm using is an M8N Neo. Okay, now there might be, but it's also a couple years old, so there may be an M9 now. Okay, but the M8 is a real good one. It does 10 hertz, yeah. And also the other thing that's nice about it is they're not very expensive. Well, most GPSs aren't, but you can get it for about 30 bucks, 31 bucks, something like that off of eBay even. And because they're used with a lot of the autopilots, it has a separate magnetometer on it. So you don't have, otherwise you might have a something like an 055. It's got a magnetometer on it, but you can also get a second or a separate magnetometer up on the GPS unit. So the other nice thing about the U-Blot is they have their own, I don't know what you call it, API. I don't know if it's an API, but essentially they have a program where you can tailor the GPS to your specifications. For example, you might not want the classic NEMA messages. You might just want one part of the NEMA message. You can fix it up. You can do that. You can change all of the modes. For example, you can use the system that the military uses, where you essentially look at a quad, a group, a block of land, and they draw it like a map. So everything is, if you're at X1 and you wanted to go to X4, that's literally what you do. You drive to waypoint, as opposed to trying to have the curvature of the Earth and trying to figure out what's going on.
Oh, nice.
So, I mean, there's a whole lot of nice things that U-Blot has on their website, tools to help. You don't have to do all of that. You can just use the standard messages. And I think David has posted some routines that will allow you. If not, you can get them off the web, where you can calculate, if I want to go to X, if I want to go to this waypoint, how do I turn it into X and Y coordinates? That's available out. Those routines are available. And some of them are even in Python. So I mean, it's pretty universal. Now, I'm not sure about all of the available interfaces on the U-Blot. I do know that the one I'm using is a serial, okay? But I believe that they have other interfaces available. So like if you wanted I2C or whatever, I think they're all there. But you might have to move a wire on the module. Do you know what I'm saying? So,
Right.
but you,
Okay. Cool information. Thanks.
and then there's RKS. Oh. Are you
RTK.
going that way? RTK? Are you going that way, Carl?
No.
You're not, Ted. Oh yeah, I'm not. I don't think it's necessary for this. I mean, we have had several people ace this contest without it. I mean, I'm sure hoping that we can get Kareem and his group to do it, just because it'd be different. But it'd be cool. We'll see how it goes.
So us beginners don't know what RTK means.
Real time. What is it?
Kinematics.
Real time kinematics. Yeah. So essentially, it's like, are you familiar with the differential GPS?
No.
Okay, in differential GPS, which is the forerunner of this, of RTK, is that you would have one station that stays in one place, okay, all the time. If it stays there long enough, even with error, it knows it'll eventually come to a decision of where it really is. All right. And so if you know where it really is, and then what the signal that it's getting from the different satellites, you can say, okay, it thinks it's here, but the satellites are telling me I'm there. So I can say the error is the difference between those two locations. And then I can send that to the other GPS unit and subtract those same error ones. Well, as you can imagine, there are two GPS units out there are not getting the same reflections from the signal and everything. It will be better, definitely better. That's how most of the agricultural tractors and stuff have run in the past. Okay, now with RTK, they actually interpret the phase of how the signal is hitting the base station, and they're actually more accurately determining the error. Okay, and I've read this several times. I've never seen it in practice, but supposedly you can literally put the base station on your moving platform. Okay, and even just the fact that they're in two different locations on the tractor or whatever, they can actually correct. You can have this like differential GPS improvement on a single body, but most of them don't do that. Most of them have a base station somewhere around where they're going. Now, I know what Kareem has done is there are stations that are that publish this information, but they're in some location and they're supposed to be good for, I don't know, 10 miles. And he uses somebody who's doing one of those stations for free. So he's not having to, he's just picking up on that. I don't know if I've been very clear about the difference, but do you understand how if you had one that knew where it was, that it would be easier for you to figure the error that's hitting?
Doug, it just makes the assumption that the error that the stationary GPS is seeing is the same error that the mobile robot is seeing.
Right, yeah.
So if I know where I really am, I subtract off where the GPS constellation tells us I am, then I can send that error to the.
Right. And
the other one is a little slicker, and it's
Yeah.
actually one of the standard GPS parameters, but you can imagine that the signal from the satellite down to the GPS antenna is a certain number of wavelengths long.
Right.
And the last wavelength will be a partial wavelength.
Right, and that's where they get the extract the
Knowing where
phase.
you are on that partial wavelength, you can use that to improve the accuracy of your
Right.
communication.
And they can bring it down with that to, I think it's about 10 centimeters, I think. Oh, it might even be better than that, but I think 10 centimeters. So, you know, that's pretty darn good.
And the military lets us do that?
Yes.
Yeah.
They
Well,
didn't
the
use
public, there's the public of accessible accuracy level, and then there's the military level, right? So if you imagine with these, with the paid networks that somebody alluded to, even though Kareem's using the free versions, but with the paid ones, you can get something like what, 2 centimeter accuracy
Something like that. Yeah.
with GPS RTK positional. So if you can imagine if that's in the public domain, imagine what the military could do.
Yeah, but the thing is, nowadays the threat to a country generally isn't missiles; it's actually cyber warfare, as we saw with the recent power cuts to the power grid, hospitals, and
there were some guys a few years ago at Stanford that built a self-piloting helicopter, and basically they did as Doug described. They actually had 4 GPS receivers on the 4 ordinal points of the helicopter, and the differences between those told them the elevation and angle and orientation of the helicopter. So pretty amazing.
Yeah, but I wouldn't start there. I mean, you know, I mean, unless you got a lot of money, then you can just buy the solution. But if you're not going to do that, U-Blot is a really good company, got good tools. They make, you know, world-class GPSs. That would be where I'd first look. Now, you know, there may be up-and-comers that might be just as good, but that's where and it's cheap, you know. So, I mean, that's where I would go ahead and look if I was just trying to buy a GPS. I believe the one that I have is called a U-Blot Neo. Give me a second here. Yeah, U-Blot Neo MNN. That's what the one that I think I've used. And you can get them in a, you know, with a shell and little breakouts to it. You know, you can always cut those breakouts off and use them for something else. But
yeah, U-Blocks with an X. I just looked it up and found it.
Yeah. So cool, you know. I mean, and they're fun. I mean, they are another rabbit hole.
Yep.
Cool. All right. Off to the races here. Ted, did you have any other questions for the group?
No, that was it. Thanks. That was helpful.
Cool. Can't wait to see how much of your robots you redo for next week. You're doing great. All right, so that takes us Doug D. I think you wanted to go next.
Yes, I'll be quick. Let me bring up my presentation window here. So hopefully you see that spinning robot there.
Oh, yeah.
Telepresence robot on Instructables that John showed us several months ago. And I've been busy buying the parts for it. And I think I've finally gotten my last parts as the wheels. And so I'm going to actually start working on it as my production telepresence robot so that we can take what I've been doing and make something that hopefully will really work. And stop the sharing so we don't have to watch that spin all night. And last week I had given a demo of using my Raspberry Pi head via DPRG API on 2 different bottoms, and the demonstration bombed on the second bottom because I forgot you had to actually shut the Pi down, or not shut the Pi down, but shut the program down, because when you disconnect from one serial thing to the other, you have to start the thing back up to reestablish connections. I'm not going to bother demonstrating tonight. I'll save that for some future event. But it works pretty slick. You just take that Pi off of one box and put it on the other box, and it just uses the API the same on the other box. Pretty exciting.
Yeah.
So that's it for me. If anybody's got any questions.
Nicely done. It's cool to see you carrying that forward on a telepresence project. That's I
We
think
got
the rest of us have kind of.
We're going to be back in the maker thing pretty soon. We don't want to lose remote people.
Yeah, we're gonna have to take care of that soon.
Yeah, I'm counting on you because it's a long drive from Denver here.
But worth every hour of it.
That's right. Hopefully we can get more than one of them working once we get a prototype actually working.
Yeah. Well, I mean, I have mine. I can cobble together pretty quickly. So there's a couple different already just between us.
Right.
Not even counting Chris's approach if we were to copy that one. So, hey, David, you were raising your finger. Did you want to say something?
I was just indicating that I was at the makerspace all the way to yesterday.
Oh yeah, I was there too. As a matter of fact,
I thought that was you.
Yeah, I think so. You might have bumped into each other there. Okay. All right. So, Chris, I think you had something next, maybe.
Yeah. Just quick. Let me. Let's see. You're gonna start with this share. So last time, we were talking about census last time. Oh, can you see my screen? Should be coming up now.
Yeah.
We were talking about census last time, and the sharp IR, the standard ones, and somehow someone mentioned, hey, but there are these newer one, time of flight distance census, right? And I bought, like many years ago, I bought this guy from Pololu. Again, this isn't like a latest and greatest. It's literally several years ago I bought this. I haven't really put it to use, but I decided to take it out of the box and see if it has any advantages to offer over, let's say, a sharp IR. Again, this particular one, if you dial down the resolution to 3 millimeters, supposedly you can get up to 60 centimeter range. Found that to be the case. I think I've seen it maxing out at 50 centimeters, maybe some parameter tweaking thing. But, I mean, it does what it's advertised to do. You can see, I mean, the numbers are scrolling by a little fast, I suppose, but I'm holding it, if you can see my, I have it connected here to my Arduino thing and just running one of the sample programs. So it's doing what it says it's doing. It's not the fastest. At the near end of the range, it spits out an update every 10 milliseconds, so that's not bad. But then as you get further away, as you get to the, let's say 50 centimeter kind of max range, it's the updates coming only every, let's say 60 milliseconds or so, right? So it's starting to slow down a bit just because I think a lot of the readings that it's getting are not good. So in that sense, it's not even faster than the sharp IR. The one advantage it does have is, again, I don't know if you can see me, but the one advantage it does have is it doesn't really have a minimum distance, okay? So you can be right up to an obstacle and it doesn't get confused by that, like the sharp IR, which, give you bogus, like opposite kind of numbers. So that's maybe the only benefit I can see. But again, that being said, I mean, this is an old module, right? And they have these other ones that look interesting, including this fancy one that they say you shouldn't even bother connecting it to an 8-bit micro. It has a much longer range. I mean, longer than I even need, but multi-target, right? You can see multiple things and distinguish between those things. So there's some interesting parts out there, I guess, that be interesting to sort of see someone benchmark and see if they offer some advantage here for low tech, or not really low tech obstacle avoidance, but something in between just an ultrasonic and the sharp IR and in a LiDAR. So I think there's some good things out there that are worth trying out. So maybe even next time I place a pull-a-loop order, I think I'm going to order one of those newer parts and try them out.
Mm-hmm. Chris, on the VL53LOX, which was their first generation, I bought several of those and messed with them. And there's probably there's a DPRG video out there on whatever we were doing. If you go back on the website, you can look at that. But the L1, if I were going to buy one, I would go with the L1 as a minimum.
Okay.
Now the other one that you mentioned that has the array, I haven't really screwed with any of that one. I do own one of the L1s. I just haven't put it on. One of the problems that I kind of had with it, with it is if you're using more than one, you have the scheme for getting different I2C addresses is a little painful, but you can have, there's a range of I2C addresses that you can have, but they all start up on the same one. So
well, I guess that's where that bus multiplexer comes in that someone pointed out to me, and I did end up buying it. Haven't used it yet, but there are these gadgets out there that deal with that problem.
Yeah, that's one way that a lot of people did to get around it. There's also a software fix that you can do where it's.
But how well did the L1 perform, or you didn't use it at all?
The L1 I haven't used. I have some, but I didn't use it. The L0 I used, and if I remember right, they were a little bit slow. I want to say they were 30 milliseconds for what I was had them set up for, and they were pretty accurate. I mean, if you didn't really want millimeter type accuracy, because they bounce around a bit. And like I say, the biggest problem I had with them had to do with trying to get multiple ones performing at the same time. And I had units that appeared to die. I mean, just boop, like they just died. And
you're still mad about it.
Well, no, but like something would happen and they would start working again. And I don't know what was going on about that. Now, I will say this, you have to be careful, because if you look at the circuit of the Pololu VL01 or whatever, or the one, you need to look at it because they didn't change the circuit. They just put the new sensor on the same board. And if you get, you might want to look at the same board on Adafruit. Like I say, there's a video and a presentation where I talked about this. It was just new sensors or something, new LiDAR sensor. Carl it's the LiDAR one. Carl went off on more traditional LiDARs, and then I had a second presentation on this. And there's a couple of things that Adafruit did that was really intelligent, where Pololu didn't do it. But the Pololu library was simpler to use than the Adafruit library. And like I say, I'll take a quick look at the website and see if I can find that video. But because it would be before you went out and spent a bunch of money, unless you've already done it, you might want to look at this and at least get what my findings were. Okay.
Chris, did you know how? Is there a beam width associated, or what is the size of the footprint, or something like that?
I'm not sure. I have looked at the spec, but let's do a quick experiment here. The beam, okay, I would guesstimate it's on the narrow side. I'm just doing this here as we speak. It's on the narrow side. I'd estimate like a 15 degree, 20 degree at most beam.
That wide?
Yeah, I mean, it's not like laser focused. It is definitely a cone. It's definitely a cone.
That's very
as I'm moving the pencil in here, it's definitely picking it up. I don't have to be right in front of it, but so I would say a 15 degree cone.
That's
and
very
Chris,
useful.
I was just looking at the web page for the 3 model, the multi-target one, and it says it's got a 25 degree cone.
That's really interesting. I'm a little confused though, because of the fact that the readings seem to take longer as the detections get further away. I thought this was speed of light.
Yeah, I think it has to do, so they need to get a couple successful readings, right? And then they give you a result. And as you get further away from the target, it's, they just barely get any successful readings back. And so they have to sort of wait until they get, a couple successful readings in a row from what I've read, and then they give you the result. And that takes a certain amount of time where you can set a timeout and it'll give up before then. There are a couple parameters you can tweak having to do with the gain of internal amplification. So I didn't tweak with all the parameters, but for sure, and I've seen that in the specs of the other sensors as well, there's a correlation between sort of time budget you give it, maximum time budget, and what range you can expect. If you want the maximum range, you have to give it a bigger time budget. But it's a bit counterintuitive, but that's how it is.
Well, I was just again looking at the spec for this on the Pololu page, and it's very clear this is kind of a smarter sensor than the Sharps are. And you have to set a mode, and then the mode determines, and there's actually a chart even on the page saying maximum distance and repeatability error versus timing budget. And there's a chart that actually says, so it jumps up to 140, 200 milliseconds, and it's obviously doing multiple pings to try to give you a more accurate output, I think.
Yeah. So, I mean, it's not cheap, the sensors. Again, I have this old one, which nowadays costs $849. Some of the other ones cost $10. So it's probably in the same range, I guess, as the Sharp IR sensor. So in that sense, they're, I guess, a good alternative to consider. A little harder to interface with. It's I2C. I mean, you can't beat an analog output from a device. It just doesn't get easier than that. But yeah, no minimum sensing distance. I mean, that's kind of the one definite.
That's great. Yeah.
Plus.
And having that wide a field of view, I just was not expecting that. I thought they were more laser-like.
Yeah, no. So the other quick thing, again, I don't have any updates to my actual the software running on my Romy platform, but as you can see, I got a very primitive bumper around it. It's a non-functional, so it's not for sensing purposes. It's just I've been, the Romy platform is not all that sturdy. I've been banging into stuff, and so I wanted to just cushion those collisions a little bit with some foam. And to deal with the wheel, I've put some thin plastic there just to kind of complete the circle, sort of, right? It's a round platform, but there's a little bit of cutout there for the wheel. So I covered that up with plastic so I can stick the foam to it. So that's all, just a little bit mechanical work. And while I experiment, so I don't completely bang it up. And I still have a little bit of that problem that I mentioned a while ago. It really bums me out. I mean, Pololu really didn't think it through with the batteries on this thing, right? I've mentioned that when I have a collision, the AA batteries, they lose contact, boom, power goes away for a split second. And I've taken some advice, right? Just stretch the springs, make everything tighter. I've tried a couple things and it helps a little bit. The one thing that in the end I keep coming back to that does seem to help quite a bit is I added a giant cap, right, to the power rail. So if I lose power for 10, 20, 30, 50 milliseconds, I don't know, I'm just picking a number, right? The cap can hold it up for that long, and then the batteries, make contact again. But it's a pretty annoying thing about this Romy platform, and Pololu really usually does a good job, especially all things to do with power on their stuff. But this one with the AA battery compartment, you bang into something, you lose power. It's pretty annoying. So, but it works fine right now between the cap and my my foam bumper. I don't have resets anymore.
Well, Chris, what will certainly happen is that as your software gets more sophisticated, you will hit fewer things, and so you won't notice it as much.
Yeah, I should just make it fully autonomous, right? Instead of me driving it, because it's mostly me who is hitting the things, you know.
Or you could put a really big honking capacitor on it.
Yeah, that's what I did. So I added I don't know 4,700 microfarad, and that does the trick.
I want to interrupt Chris here just for a moment because I'm trying to fix a flat, and I want to say something. Doug, or Carl, you just saw the link, and I'm sorry it took me a while to get it there. Murray, I've seen that same sort of fella jumping around on several Discord channels wanting to update stuff, so I'm thinking there's something more going on there and put on rolls, exact same verbiage and language. So stay away from that guy. And I got my tiny LiDAR in. So that's all I got to say, and I'm going to go fix a flat. All right.
Good
Well,
luck, Harold.
I was done anyway, so.
Well,
Thanks.
I didn't mean to be rude, and I know it was rude, but I'm trying not to let my tire blow up, and I got to, never mind.
Thanks a ton, Harold. Good luck with that.
Okay. I mean, I'm going to stay online here as I run back and forth, but.
Just don't drive your cars on the rim. I saw a car up in Pittsburgh. Well, it was here before I went to Pittsburgh, and I thought something was funny about it. Then I drove beside it, and the person had apparently driven their car with two flats, and they drove it enough that there was no rubber left on the rim. It was just steel rims on the ground. And I went out and did an errand and came back, and he had driven off. So I mean, poor road, but we know Harold won't do that. That's good. Okay, and that takes us to, I think, John G. I think you're next in line.
Hi. Well, I was working on my robotic spider leg and ran into a little problem. I'm powering it with these little Pololu 12-volt micrometal gear motors, and I had miswired or maybe had an incomplete connection on one of my limit switches and hit the end of the motion and broke the motor. Well, I thought it was maybe defective, so I emailed Pololu, and they explained to me that these motors, particularly the high torque ones, they will self-destruct if you stall them. I mean, the motor will output 3.3 centimeter kilograms of torque, but the guy at Pololu said, well, the gearbox is only designed to handle 2. So now, of course, I can correct the wiring on my limit switches, but it also occurred to me that if my leg is operating and hits any kind of resistance that stalls the leg, I'm in the same kind of trouble. So I think I've got 2 options available to me. One is current sensing and current limiting circuitry, which I've got a custom motor driver board that I designed and built myself. I could do that. Or the PIC software on that board does have a PID. I did write a PID algorithm for that. And I could try to detect a stall with the PID algorithm. And I was wondering if anybody had suggestions on which way to go.
Question for you. Do you have any idea? Sounds like it basically that motor gear assembly is not rated for stall.
No.
So
Found that out the hard way.
do you have any idea how long of a stall condition it can tolerate before it fries itself?
Well, the guy at Pololu didn't say, but he explained that two things can happen. The one thing that did happen was the output shaft separated from the last gear in the gear train. These things are really, these little motors are really powerful, the 12-volt ones. The other thing that can happen if you let it stall too long is, of course, it'll burn up the coils. I don't have a good feel for how long of a stall, how much play I have, because I imagine that if I try to use PID, the challenge there is, in particular, trying to differentiate between the time you need to start to get the motor up to speed and the amount of time you need to detect the stall. And because you don't want it to stop every time it starts out. And I've been told that maybe David had done something with this before. Maybe I could ping him for an idea.
Well, this is the age-old problem you're describing. Let me be sure I understand. The construction of the hardware itself, of the motors themselves, are such that they can generate enough torque when stalled to tear up their own gear head.
Yeah.
Okay. Now I've seen that before, and even on motors where that won't happen, because electric motors, have maximum torque when they're stalled. So basically, that little pinion, a little pinion can act like a router bit and just grind all the gears, all the teeth off of the next gear in the stage. It sounds like something like that is what happened. And so part of that problem is just allowing that value to change that quickly. I need to think about it a little bit because it seems like that the simplest solution would be to find motors that can stall without tearing themselves up.
Yeah, I specifically selected these. I'm getting that. Somebody feedback.
Maybe it's me.
Oh, yeah, that was it. Yeah, I selected these motors specifically because they have such high torque, and I suppose that's one of the options. I could go with try a lower torque motor and see if it will still drive my spider leg.
Well, does it become a lower torque motor simply by driving it with a lower voltage?
Probably.
Yeah, I suppose I could probably drive it with 6
it
volts
has to
instead
be
of
lower
12.
torque. You give it less power, right? You're not giving it as much power.
And I could probably also, I'm using pulse modulation to set the speed. So I suppose I can also just always operate at a lower speed. I tend to kind of go over the top in terms of performance that I use rather than what I need.
Well,
But John,
David, these motors come in both the 6-volt and 12, and they also come in normal power and high power. And the 12-volt high power are really high torque for the size of them. They are, they're the same size as the 6-volt, and I think they've got something like 4 times the torque or something like that. They're quite powerful motors at 12-volt, as John said. And the only thing that I had suggested to John when we were chatting about this was that rather than sort of, as I use the word, pollute the PID controller, was to add external to the PID controller a slew limiter, basically, so that you would ramp up the speed gradually as you apply power, or not power, as you suggest to the motor controller that it should gradually come up to speed.
I don't think that really helps in this case. The case in which that helps is when you're suddenly switching the power, like if you go from 0 to full speed and you want to slew to full speed rather than do that sharp edge. But in this case, you're going to end up at full speed anyway. Yeah. And I realized as I was saying that John chose these motors because they're powerful, and you say, well, give them less voltage, make them less powerful.
Yeah. So couldn't you just look at the David? You're causing a echo. I'm gonna have to mute you. Couldn't you just sort of measure the current, right? And as long as hopefully they can survive a stall for just a little bit, right? So if you could measure the current and then integrate over time, and then and then shut off just before it's too late, right? Wouldn't just a simple scheme like that work?
I think that the point John was making, what I said is the ancient problem is that, okay, well, I do that and it fixes this problem, but it introduces this other problem, which is that now when you're trying to spool up, it gets interpreted as an error.
But when he spools up, there'll be a short spike, right? Hopefully that spike will be shorter.
Maybe so.
The way I was looking at it in the conversations is that we've had lots of discussions around slew limiters, and they operate kind of at a meta level above the PID controller. And what I was suggesting is that the slew limiter acts as a measure on top of the PID controller, and that it would be, I wouldn't say trivial, but it would be an exercise in writing something like a slew controller that would be effectively, what would we call it? In any case, it would have configuration in it that would suggest that it would look for a certain kind of characteristic that suggested a stall. That if the motor controller was saying go at this speed and the motor was only spinning at a certain speed for a certain amount of time, that would be indicative of a stall, and therefore it would then shut the thing down. Something like that.
Seems like it'd be easier to do that in hardware. That is, just
really?
just make the system so it won't break, so that you can't feed a voltage that breaks it.
Yeah, and it certainly sounds like the safest way to go, right? And I've already my motor driver board is already a custom board. It would be just a matter of me. Well, and once again, it still comes back, David. It still comes back to, in the hardware design, distinguishing between startup, the startup current, and an actual stall.
And there might even be other times in the operation of the leg where it's pushing and heaving, and you get these big spikes of current that are actually not a problem, that are part of its normal behavior. And I guess what Chris was suggesting would be you sort of have to study those and try to isolate out, the bad guy that you're looking for.
Yeah.
And that just all seems like a lot of work.
Yeah, it is. It is. I mean, I think I've temporarily solved part of the problem by fixing my limit switches, but that doesn't fix the problem during normal operation where you snag the leg on something. The limit switch is not going to solve that problem. So,
I wish Kareem was here, because at one point, one of his teams, where they were given a big box of materials that they had to use, the motors that they were given blew up all the time. And it seems like it was this same problem. The kids were always blowing up the motors. And I think finally they managed to get some other type of hardware put in the kit, where it just was more difficult to blow things up. On the other hand, I mean, what you say makes perfect sense. It's like, I flew my helicopter into the ground, and it broke it all up. And so, the problem really was that I flew it into the ground. I mean, this is not normal behavior.
Hey, John, could you link the specific motor version that you got from Pololu?
If you're on Pololu looking at metal gear motors, it's number 3056. Actually, you don't even have to look at gear motors. Just go to Pololu and enter pound 3056, and that'll take you right to it. And I asked the guy at Pololu, I said, well, can you recommend an upper limit for the gear ratio on the motors? He said it's particularly a problem with their higher torque motors. So I asked him, can you give me a recommendation for the highest torque motor that you have that isn't susceptible to this? And he really couldn't give me an answer on that.
But
essentially, I'm asking him, tell me what's your highest torque motor that doesn't self-destruct when it stalls.
Isn't it so though that isn't it so that the torque is going to be pretty much proportional to the current, generally speaking, yes, for a fixed voltage? It will be, right?
Yeah.
So if the trouble is that the motor is 50% higher torque than the gears can support, then it seems like if you can, like, for example, calibrate and measure the torque that the motor is pulling out, you could measure the current that it takes to produce that torque. And then if you had current sensors and you could average that over some whatever reasonable time period was, then you could set, maybe Murray described it as a slew limit, but I would think of it as a torque limit. Yeah. And you would structure the PID loop so that the output could never exceed that torque, that current. And that way you could I mean, it would be safe in the way that it wasn't a hardware solution because the motor is still technically more powerful than the gears can support. But if the source and the driver are configured so that they'll never send more than that torque, then you should be okay.
Yeah, so technically, I wouldn't even have to change the supply voltage since it's PWM. What you're saying is just set the upper limit on PWM and
well, not there. But you'd have to set that limit based on the current, not the PWM, because you don't know what PWM will produce what current.
Right. At some point, you have to do some empirical, gather some empirical data on the relationship.
But I think it's a safe bet that, I mean, the motor's basically a constant load out there, depending on its RPM, and that if you want to set an upper limit on the current, you just set an upper limit on the voltage.
Well, yeah, like for example, if it can generate 3.3 centimeter kilograms of torque, and I'm currently running at 12 volts, let's say full on PWM, then just basically take, if you want to get down to 2, just basically go 2/3, right? It should be linear.
The one thing that occurs to me, and I wasn't expressing myself very well earlier, but yeah, the idea of having a torque limiter is really what I was looking for in terms of terminology, similar to a slew limiter. But it does occur to me that, let's say, for example, you either through what you guys have been talking about or through choosing a different motor, go to a motor that can no longer tear its gearbox up, but now you've got maybe what maybe more of us are used to, which is a motor that simply gets to its limit and can't go anymore. So it can't lift that spider leg anymore. And so it's no longer tearing the gears up, but now it's overheating and burning out the coils. So you need the solution you're looking for is for the same thing. It's either burning out the coils or tearing out the gears.
Right. Yeah. Even if I did reduce the PWM, I could still risk burning up the motor on a stall. Sure. Although I'd probably have more time.
Yeah. Hey, John, what was that, the number again?
3056. Interesting problem to have, no?
Yeah.
Of course, what you really want, ideally, is you say, well, I would like to have all the torque available that I need when I need it, but somehow be able to sense when it's getting ready to break something. I was saying if you probably would have to do some destructive testing here, because what you want to do is, ramp the voltage up until it breaks and then back off a little bit.
Well, I think
you got a lot of $9 motors to do that.
You want current limit, because current is what the torque is.
Yes.
So I'm thinking, can you build like a clutch type system with a spring that is, if it hits certain thing, it would basically disconnect?
It's not really this design is not really conducive to that. Everything is very small.
Well, it would be a miniature crunch.
Yeah, that's one of the reasons to go with this motor. I mean, we're talking about. Oops, I can't. That's it. I mean, the motor is right in here.
Yeah, right. I understand. That's why I said miniature crutch like type thing.
Well, John,
so that it disconnect.
RC race cars often have a spring-loaded deal on the front to steer the front wheels, because when you slam into a curve, it breaks the servos all the time. So there's this little clip thing that's got a spring in it that normally has a tight connection. And they're not very big. I wonder if you could harvest one of those off of an old RC car.
So at least that way it'll be $1 breakage versus whatever.
Don, can you picture what I'm talking about? It's like you have like a little spring ring, and inside of it, it's holding this piece in place. So they normally rotate together. But if there's too much torque, that spring will move.
Yeah, they call them Servo Savers.
There you go.
And you can get them. If you look up on eBay, or go to a hobby shop, whatever.
Well, John, that's actually an interesting idea. So just protect the motor from shocks that are larger than what it's expected to survive.
Well, lots of excellent ideas there. I'm going to yield the floor, but thank you all for all those suggestions. I'm just going to have to study the problem for a while, and maybe break a few more motors. I don't know.
If you do it, just instrument the measurement on the current while you're breaking it, right?
Well, I do have, whenever I design one of these boards based on the microchip PIC, I always put some spare debug pins where, I can actually instrument some of what's going on in the PID algorithm by outputting, say, D to A of the actual position and or speed on those pins. So that although that's getting a little bit more complicated, but it would be nice to be able to instrument stuff like that.
But with your current controller, your present controller, you can actually watch the current while you change the PWM value or whatever, and see what that's doing to the what's actually going to the motor. I think that was Dave Ackley's point, that the torque's not really proportional to voltage; it's proportional to current.
Right.
And so if you have a way to measure current, that's a better. Did I say that right, Dave?
Yeah. Hey, John, the other thing too, did you see the notice that Pololu puts up on there? They're basically saying that for that motor, you should never run it over 25 ounce inches or ounce inches. There, if you look at it, there's a statement. If you go down that product page,
the Pololu guy pointed that out.
Yeah, I'm sure they did.
That's very nice of him.
Yeah, but what I'm trying to say is you're running 46, so you're almost double their limit.
Yeah, and he was really nice about it. He said he'd even offer me a discount, even though I really misread the spec and broke the motor. But I told him, it's like I need a lot of time to play with this before I figure out which way I want to go. Like I might even buy a lesser torque motor. So yeah, I got a lot of time to figure this out.
There's some of the same things with their 25 millimeter motors, or they have a few that can do the same thing. And so I always try to buy, I always try to buy below the brake limit, especially after Kareem's experience with, they had some, it's the system that Murray uses a lot. They had one of their motors that was the one that you make that has all the nice holes in it, and you put it in, and they made a motor that really couldn't, if it ever stalled, it was dead. And I mean, when we say dead, it was like if it stalled, it died. You don't, none of this, well, I had it stalled for 10 seconds but I was lucky and it survived. If it stalled, it was dead. So if you're going to make another order, I might stick a few that are inside that limit. It looked like you were trying to get about 100 RPM. Is that?
Yeah, that was it was close to 100 RPM, the model I was looking at. Now the interesting thing is that the worm gear in my linear actuator there is 3D printed, and I can actually change the pitch of the worm gear and go with a faster motor that has lower torque. That is one of my options, and I may actually go that route.
Yeah. The problem with the Servo Savers is they're really made for impact. Otherwise, what happens is when you hit something, instead of snapping the horn off, what you do is it actually, the Servo Savers slips. But I don't think it's a real continuous clutch. I think it's basically a ring that when you hit it hard, it expands a little bit and then it slips. So if you could put another thing that they use a lot in RC cars is a friction plate, or a slip plate, they call it, I believe. And it's literally just a one plate with a piece of sandpaper on it, and they have another plate that fits right onto it, and they have a spring that holds the contact, and then they just adjust that spring so that depending on the torque, the thing will slip if it gets above a certain value. So I mean, you might be able to do that.
Yeah,
And
this is-
that basically was why I was thinking something on that
yeah,
lines.
that sounds
yeah.
like what, yeah, I agree with you, John. That sounds like what you were talking about.
Yeah, it's pretty compact design to be difficult to do that. These little motors are incredibly powerful. I mean, today I almost, well, actually I did stall out, but it didn't break that motor.
Mhm.
But in the joints of my robot leg, I have these like 3/64 inch brass rods that I cut and make the axle on these joints. It actually bent one of those.
No.
It bent a 3/64 inch brass rod when it stalled out.
Mhm.
So they're incredibly powerful.
Well, you know, I thought that same thing when Chris was talking about his robot running into things, that especially if you get a good PID controller working, these little motors can generate an enormous amount of power. And when it's doing that in a way you want, it's all good. But when it's like rammed up underneath a bookcase and trying to lift the bookcase up in the air and breaking things in the process, it's like, no, stop. For at least for our case, until your battery runs dead, you know.
What do you guys think about a resettable fuse? That might be another solution.
I did a little research myself, and I saw somebody mention resettable fuses, but it might have been, I'm trying to think what I was looking at. I think somebody was saying, no, that's never a really good idea. They said something about, don't those fuses have a limited lifetime?
Yeah, they every time they get hit, they slightly degrade.
The
But
threshold changes. Yeah,
Yeah.
I don't think they're made for that kind of use case, basically.
yeah. Well, they use them in hot plate on 3D printers a lot.
Well, you
So-
know, if they're socketed, if they could be removed, I could make them part of my driver board design. You know, and just
What about one of
replace it,
these?
be replaced.
They have these little current boards. I've seen. I think somebody in the club has used them, where you can just monitor the current, and you can just
Yeah,
have it.
INA 260.
Yeah. Now I know they used to make them pretty but low current ratings, but a lot of them are really high. They're like 10 amps or 20 amps. But they basically give an ADC reading on current.
Right. But
And-
see,
and-
you're back to the same old problem of trying to distinguish a startup current to a stall current.
Well, John, couldn't you basically emulate those fuses anyway on your board? You can measure current. You can turn off the current if it gets too high.
Yeah, that's one of the things I considered is put some current sensing circuitry on the board.
And
Once
then
again, yeah, I could do that. And the real challenge there is, as I pointed out, is gathering enough empirical data on the operations so that you can distinguish startup current from stall current.
But it strikes me that, I mean, this is what I was asking before, if it's proportional, because if the startup current, it seems to me that the startup current, I mean, if it's going to be like if so many amps are stalled, that even if you achieve that during startup for a period of time, you're still going to damage, you risk degrading things, even at startup. Because if you're trying to start up under load, if you're going to try and slam into a limit, you're still trying to drive a lot of torque into the motor, right? Whether the torque is because the motor's not spinning yet, or because you ran the motor into a limit and it got stuck. Either way, torque is torque, right?
Right.
Yeah. That I would say is right, is that you don't want to say, well, I can have it for this long. It says, no, I cut the PWM down so it doesn't exceed this current, period.
So in that way, if you set your PID loop up with a current feedback as a part of it, and if you use the current feedback as a limiter on the output of the PID loop, then it should be safe. You can drive the PID loop full on, but that limiter in the feedback is going to prevent it from ever going beyond the capability of the gears to support.
Well, that's basically a stall limiter. It's like a
Yeah.
slew limiter, but a stall limiter using
It's-
current as input.
It's an output limit.
Yeah, it's not
Well,
slew. It's not a slew limiter because the slew
No.
limiter would
No, I
into.
understand that.
Yeah.
I understand that. I'm just saying that like a slew limiter, but using current.
But I think what Dave is saying is you don't need to do any of that. You just limit the maximum amount of current it can draw by limiting what the upper PWM value can be.
Yeah, as a matter of fact,
I have done that. I know. But I will say though, if you on most motor controllers, you may have access to. They usually have a current sense resistor as part of their circuitry, and they usually bring that out, and you could use that. Sometimes they use external current, external resistors, which may not be on your motor driver module, but they might. You just have to check. And if they have the current sense leads out on the motor control board, you could use that to determine the current that's going to the motors.
Yeah, well, actually, my motor driver is a custom board of my own design,
Okay.
with a microchip PIC on it, so I can add to that. It's I've already started looking into current sensing circuits and thinking about how I might incorporate that into the motor driver design.
Yeah. Okay.
And after all of this discussion, I think I'm actually thinking of along the lines of taking multiple approaches. One would be that modifying my driver board with current sensing, and limiting my upper limit on the PWM, and going with a faster motor with lower torque and changing my worm gear pitch.
That might actually be beneficial because you got so much mechanical advantage with that worm gear.
Yeah, I think I might do all three of those.
You'll have the most robust robotic spider in town.
Too bad
Cool.
it can't actually walk.
Next year.
Maybe that's
Cool.
next generation. Next generation will
Yeah.
be a walking robot spider.
Very nice.
I've seen lots of those hexabots, that they use. But it's a real challenge. The weight versus a strength factor on those is pretty challenging, I imagine, to allow those to walk.
Cool. All right. If nothing else, then let's. I think Murray, you were next in line.
Yeah, and I will push the button here to let you guys know I've just posted a new blog entry, which is kind of the summation of my club robot journey. And I actually kind of quote David in there. So if David thinks I have possibly mischaracterized what he said, please let me know. I'm happy to edit.
I'll sue.
It's kind of hard to do that across the country boundaries, but you go right ahead. Anyway, if you let me know if you think I've mischaracterized what you said, and I'm happy to edit it. But in summation, I now have a little Zumo that I have gone to a huge amount of trouble to get motor encoders and bring them up onto the top board. And it's all done. And kind of what the point of the article is now that I've done this, I don't really want it. The thing is that I'm not a C++ programmer, and I don't think I could be bothered going to the trouble of doing all that software tooling that I've done in Python again in C++ for this robot. And I like the idea of maybe having a sumo competition, but it comes back to that whole question. This comes back to David's question, which was, why the hell are you even bothering, Murray? And it is really that what this comes down to is that, do I really want this robot now that I've gone to the trouble of building it? And the whole idea of a club robot. So I tried to explain that in this blog post, which I won't bore you with the details of because you can just go read it. But I guess the thing is that what I'm going to do with this now is either sell it or take the top of it off, which is the Arduino Leonardo, and try out the Kictronics board, which is an RP2040 Pico board that can be programmed in MicroPython. And so effectively take all the top of this off and just use the chassis and the encoders and try to do it in MicroPython, because I still kind of want to try to port my CPython code over to MicroPython as much as possible. But that whole journey of trying to spend, I spent a fair bit of time and money trying to come up with a club robot for a club that doesn't exist really. There's no members here. I haven't gone to a local school because of the pandemic, and now because I'm too busy building robots, which is kind of David's point. So in any case, that's kind of as far as I've gotten. Now I can begin to again refocus on building my own robot. David, is that like a little bit of that maybe?
Sure, why not?
Thank you. And I've spent, God, I don't know, well over 40 hours. I don't even want to think how much time on this Python async IO message bus, which I was doing wrong. Now I think I'm doing right, but writing a asynchronous message bus in Python without multi-threading is exceedingly difficult. There isn't one out there. Maybe there's a reason for that. But I've sat on the train every morning with my laptop and tried programming this thing, and I easily 40 hours. And but I'm kind of basing my whole subsumption architecture on that, because there's what's called blocking IO and non-blocking, and you can't, if you've got a 20 hertz loop, you can't have one of your processes blocking for 80 milliseconds. So I'm still working on that. Hardware-wise, what else is going on around here? I think that's it. I kind of got to the point where now I've got this finished, and I might try the Kictronics with the RP2040 and try MicroPythoning it. But I think what I'm going to probably really do is get back to my main robot, the KR01, or maybe the differential one, and start getting that to run, maybe or maybe not using that message bus. It's tricky. I've got it kind of working, but not really. Not to my satisfaction anyway. I could try to program it in Java. But in any case, that's kind of it from New Zealand. The personal robotics chat board has been fairly busy. Harold pointed out to me some young guy who'd gotten in touch with me who admitted privately that he's got some mental health issues. I don't think he's actually the problem that Harold thinks he is. He's just someone a bit misguided who's trying hard to figure out how to communicate with other people. Turns out that I've had a few people that I've run into with mental health issues in this chat board, and it's I hadn't thought about that when I started this thing up, that you, as the admin of a chat board, have to deal with people that in face-to-face conversations they have a great deal of difficulty. Yeah, that's, I guess that kind of goes with the territory though. But that's kind of it from New Zealand.
So how's your fusion coming along? In that design?
Yeah, I can report on that. So that's with regard to the PAA 5100JE. I'm pretty pleased with it actually. It's not high performance any more than the other one, but this is the near optical flow sensor. The downside is that its upper limit is 35 millimeters, which underneath a small robot is actually fine. But if you're going to put it on a Mars rover, you're actually farther above the ground than that. You actually want more ground clearance than 35 millimeters. So I think for a four-wheel drive motor robot, like outdoor robot, it wouldn't work very well at all. And you'd probably go back to the other one, which has, I think it's 90 millimeters minimum distance to infinity, versus this one is 10 to 35 millimeters, designed for robot vacuum cleaners and things that are close to the ground. I did get an update to the software from Pimoroni, and that upgrade made a significant difference in the performance. This is actually now the difference between the tile floor in the bathroom and the fence paling, which were the two extreme limits, isn't actually that much. It's about 20%. So this thing does have some sensitivity to what it sees, but it seems like the software update did make a big difference. And I think that there's no way for a device like this to be able to operate over any varied surface with more accuracy than you can maybe expect. Because it's trying to figure out what it sees, and it's got a, I can't remember, it's a fairly low resolution camera, and it's basically seeing how many edges go by the camera over time. And if you're on a constant surface, let's say a wood floor, it could be optimized for that surface. But if all of a sudden it goes over something that has a much higher or much lower density of information, how is it going to know that? So I think maybe we were asking too much to think it would be perfect. But generally speaking, over all the different, I think I tried 9 different surfaces, with the software upgrade that takes it from the older sensor to the new one, this is a lot better with the new software. It did something. It's one of those magic, what do they call it, magic sauce or whatever. There's some kind of a calibration that gets sent to the board as a bunch of binary data, and that apparently tells this chip what to do. So yeah, and unfortunately, Pimoroni they've got it on their website now, but they haven't had it in stock yet. So they must have had some issues getting parts. They showed me a photograph of their fab, and they'd made at least 100 of them, but they maybe gave away or sold or whatever, tested 100 of them, but they haven't got them for sale yet. Even 10 of them, they're just not on the website. But there's, yep.
What does the output of that device actually look like? What do you get out? What kind of information does it give you?
Well, it's an I2C device that streams data. It doesn't stream any data if there's no movement, but it's basically interrupt driven from what I can tell, and on the board itself. And it just sends XY data. And
does it stream at a constant rate, or is the rate changed depending on how fast you're moving?
The latter. You basically get XY data as the thing is moving. If the robot comes to a stop, the data stops. But the output from it, I'm sorry that I haven't actually posted. I've got a blog post on this that I haven't finished, and I should, because I kind of owe Pimoroni that anyway, since they sent me the board. But and I'll do that this week. But well, maybe not this week. I've got a whole bunch of stuff happening this week.
Does it give you any rotation information?
No, it does. If you were to take the board and rotate it, it doesn't actually change very much at all. In fact, I was testing that. So if I rotated the robot in place, or the board in place, you can see that the XY changes only like 1 or 2, 3, 4, versus moving it even just a little bit, you get like numbers in the hundreds, big numbers. So
that 1 or 2 are probably just that you're not staying exactly centered as you rotate it.
Exactly.
So could you use 2 of them, put one, inside each wheel, pointed at the floor or something to get
Sure. And that was kind of, I think, Chris's idea, was having 2 of them, just off axis. And yeah, I think you could. And you can change the I2C address in software, I believe, on the board. It does have a fixed it's SPI. So on a Raspberry Pi, you can have 2 SPI devices. So yeah, there's SPI 1 and SPI 0 and SPI 1 or something like that. So yeah, you could have 2, but not more than 2. But that would be enough. But I think I'm probably looking at using just one of these, because I'll have an IMU and I've got a wheel odometry. But I'm probably going to try putting one of these. I mean, I went ahead and I came up with a little mounting bracket like that. So that basically fits into a mounting bracket that I made out of aluminum. And so I can just, with 2 bolts, 2 3mm bolts, bolt that to the underside of my robot, or any of my robots. And I'll get additional visual odometry information. I would just use that to supplement. I think it's a pretty positive result, though. I think this is a pretty good sensor for a small robot. I think it could provide data that you couldn't get otherwise, like for a Mecanum wheel one.
Yeah, that's cool.
Well, that's kind of what I'm planning. Is I've got this little tiny Mecanum wheel robot, and it's got lots of space underneath, and it's about 20 millimeters off the ground. So if I was to mount that right underneath there, or even 2 of them, like you said, I'd have enough information coming off that to basically get odometry without using the motor encoders that are on the wheels. So that would work.
Murray, you
Carl,
mentioned.
Carl
you
let me
mentioned the
drive
blog.
his.
Go ahead.
Go ahead.
You mentioned a blog, Murray. Is that on the DPRG site or on the Discord or somewhere else?
You can just go to robots.org.nz.
Okay.
John, check the chat window. Murray put a link to his latest blog there, and you can see from the root domain, he's got a pretty full website. It's really quite impressive for
Oh, wow.
a band of one.
Yeah, it's taking up a fair bit of my time, I guess.
Yeah, that's what he does with the other 90% of his time.
Yeah, I've got band practice. We're actually my best mate is my bandmate, and he's got a 50th birthday on Saturday, so he's rented a local hall. So we're recording in a hall on Saturday. So there's other things in my life taking up time too. Yeah.
All right. Well, thanks, Murray. That's cool.
Yep.
I think, actually, David, I think you had mentioned at one point that you were going to say something about the Mecanum wheel, and that's actually, that's what Murray just showed is very much what I'm planning to try in one form or another on the Mecanum wheel robot that I have, the little asteroids hover sim thing.
Well,
Except I'm
Carl,
noodling over whether to use two of those or to use one of these, which is the OpenMV H7, which can also do rotation. It's not just limited to XY translation. That would be this guy.
is it? That's a little camera.
A little camera. It's like the CMU Pixie Cam or something, but it's got a small subset of OpenCV in there, or maybe not so small. I don't know, but it's pretty capable. And well, I think I mentioned before, but I'm gonna play with this next first to get the orange cone detection going for the August contest, the Outdoor Robo Columbus thing, and then time permitting, then I'll try and play with its optical flow capabilities and compare, and then put like a wide angle lens on it, have it facing down in the middle of a Mecanum wheel robot.
Mm.
And make a frame just on Mecanum wheel robot just for this in the middle, because then right now I could use it not only for optical flow kind of odometry, but I could also use it for that. Remember that contest we did last December, the virtual challenge course follower? Well, here's a camera that can get me the information that matches the magic sensor I used, right? So,
But Carl, what's the minimum focus on that lens?
well, I haven't even really looked at the lens that it comes with, because in a way I don't care, because it's M2 capable lens, and you can easily find really wide angle ones with different focal lengths.
Okay.
How much was that, Carl? How much was that camera?
This is the OpenMV H7 Plus version, so it was like $80, $85, something like that, and then too much for shipping. But
what is the interface?
I believe it's quite flexible. I forget exactly, but I think you can do anything from USB to SPI to I2C. And you can run, they actually, I want to say that they have like a subset of Arduino compatible headers on here. So I think you can, and it's actually, anybody remember, is it an M4 or M7 Cortex in there? But it's a pretty capable little processor. So you could actually use this as the main processor on your robot if you wanted to. And then just write your robot in MicroPython and then have it write to the PWM bridge or whatever you use and all your sensors if you really wanted.
How much memory does it have?
You know, I would refer you to the website. I'll put the link in there in a minute. I forget the details. I got as far as ordering this, then I went to see my folks in Pittsburgh for 2 weeks. I got as far as plugging it in and running most of the demo routines and seeing how it worked and getting the little custom IDE they have running. And being pleased with what I found.
How
And then
did
I
you
had to
talk
pack
to
and
it?
go to Pittsburgh.
For your demo, how did you talk to it?
Well, the demo, once you buy it, it's just a USB cable to your Windows box or whatever. I don't know if their IDE runs in anything other than Windows, but they port, they can stream data pretty quickly across USB, so you can see real time the image that it's capturing, and then even it'll annotate the image, and like OpenCV, you can take different points in your processing pipeline, and you can have those exported as the image that it views in the IDE. So you can, all in the one little IDE, you can look at the code, you can look at the output from the camera or whatever test points you have in your processing stream, and then you can look at the raw, like if you write to the console text output, you can view that at the same time as well, and control it all right from the IDE. So it's really a pretty nice little environment. I wish I had this 5 years ago when I first did and I chose to go RoboRealm with my cockamamie distributed approach instead of something contained like this.
So they also sell a bunch of shields that are, some of them are really nice. There's an LCD shield that I have, and you can show the picture, and you can draw like boxes on the LCD shield so you can see right on the camera what's going on.
It fits on the back.
Yeah.
I ordered one of those. Thank you for reminding me. I ordered one and I can't remember if it's canceled or they screwed me. I got to chase that down.
Yeah. Anyways, if you're ever able to get it, it's really useful to put on the back.
Yeah, because it's immediate feedback. But they have black and white. They've got some shutters in here, so you can do like high speed conveyor belt manufacturing kinds of things, fast sample rate. So instead of blurring that you get with this, so they got the shutter, they got infrared filters. They got a bunch of neat things.
Carl, can you put in a link?
I will absolutely put a link in. Yeah. And at some point when I get, Ray has already given some demos of this at one point or two in the past. So I was going to supplement what he's done with my own little experiments once I actually do my own little experiments. Maybe I can buy some time from Murray. Murray seems to have a lot of time. Okay. So I had one question, actually. I wasn't intending to go down the optical flow detour. But my question is this. It relates to practical things for 3D printing. So I've noticed that there's at least one model file. Boy, that's weird how this display is flickering, isn't it? I don't understand. So I found a model file. Somebody's mocked up a nice crawler-sized wheel, and they've asked here if it's realistic and feasible to print something like that using NinjaFlex or something like NinjaFlex. Nobody has responded to his question, or maybe I didn't read all the comments, but what's the thought online here? Is this real? I mean, look at it. It has a kind of a hollow interior. It's got a bead on both sides. It's got
Okay.
quite a lot of detail.
The hollow I was going to give you a maybe because the tread might work depending upon you did it with like a 100% infill or make everything lines, make new enough shells where everything's lines. I'll give you that. But as soon as you try to print, let's say you lay that tire down flat, which you probably are going to want to do. The overhang here, as soon as you try to print off into that, it's just gravity is going to kill you. Gravity sucks.
Yeah.
So that style of tire. Now, if you wanted to print more of a solid tire where the inside of it had infill in it itself, that had little striations going in it, that absolutely could be printed, although the definition on your tread may be a bit crazy. That's my thought. I know John has done a lot of printing and some other people, and Doug's done a lot of printing. So, or Mr. Anderson has too. So they may have different thoughts. But
Yeah.
I printed about, I don't know, 250 grams, 300 grams of Ninja Flex type stuff, TPU, both white and black. If you do support, see that blue one right there? The guy's got the blue. I've been told that, and I haven't tried it, support and Ninja Flex and TPU are not the best of friends.
Yeah, you have the problem of cleanup and that. So
Clean it
yeah,
up. Yep.
that would be the issue. It depends on how deep those treads are and stuff like that. But yeah, I would say the cleanup, it would be the biggest question mark.
What about like double-headed printers? Because I've understood you can
Get
you can-
washable stuff. Yeah.
yeah, have the washable structure and build a Ninja Flex on the washable structure, then melt the structure
And
away.
I haven't combined the two together. I actually do have a double head printer, but I tend to not use the double head part of it. But in theory, you could do that.
Part of the problem with the Ninja Flex, see, I think that guy's got some crap off in the middle of his.
Yeah, you can see there in the inside.
Part of the
Well, one solution would be to print it in outer space. I mean, come on, guys.
exactly. Part of the problem with Ninja Flex and CPUs and all that rubber is retraction. You turn that completely off when you start doing the TPU. So retraction is pulling it out and then shoving it back in to start again. That plays hell on that flexible filament because you never get it pulled all the way out. And when you go to shove it back in again, it never fully engages again. So you're going to have over extrusion and under extrusion, over extrusion on the inside and maybe under extrusions on the outside when it tries to engage after that retraction again.
Well, Carl, maybe I'm being a little dense here, but it seems like that rock crawler tires, well-made rubber ones with tread and everything, are available at hobby shops all across this great land. Why would you want to print one?
Well,
rather than just buying one?
Yes, this gets back to the other thing, right? So
customization is the key word there. I'm thinking why you would do it.
Hey man, if I'm peer pressuring you by saying 3D print your whole robot, okay, good.
David, you're not allowed to be the voice of reason against this cult of 3D printing.
Yeah, so this is, and the answer is there is no rational answer to your question, David. It comes down to this. So if you remember a couple of meetings ago, I showed my brother's RC truck from, it turns out, like 1978, that I was thinking to use as a platform for the August competition. And then I went to find spare tires because it had tire rod on all four tires. And it turns out they've never been made or remanufactured since. And it looks like if you have ones that are running, you can actually get, like, there's a couple of unopened kits for like $1,800. So, I mean, so first off, I realized that this was not going to be something I'd hack on just for a robot contest. Plus, it doesn't have much clearance. And then I thought, but it could be a cool thing as a restore project. So, for Doug D's premise that his first inclination that I should try and restore it. Of course, I don't have any better sense, so I've decided to do both. I'm doing a different approach for August, and I'm going to restore my brother's 1978 vintage Cheetah. But anyhow, so because it turns out it was one of the first made that had off-road suspension, and as such, it's got some interesting history to it. So, and look, you can get a new tire for $100 a tire, although it's new old stock, so it's going to be tire rot, right? So that's where it came from. I was thinking.
That's a good answer. That was a good answer.
You know, tell me, of all the things we do on this group and in this club, it doesn't have to make sense, right? It just doesn't have to.
Well, it's a bit like people who post on the Raspberry Pi forums and want to install Windows 10 on a Raspberry Pi.
It's there. We do it because it's there. That's why. Hey, Carl, if it makes you feel good, you roll with it, buddy. I'll support all of that. I'm an enabler, man.
Okay, well, that's my question. I thank you all for the feedback. I actually I found some, it turns out that particular model my brother has was the It was built on, there was one generation before it for off-road that this company made. And that generation was actually then re-released 20 years ago. So I got some 20-year-old re-release parts that look like they're almost compatible with this one with a minor like remount of the hole. So I got a set of tires and wheels for $50 total, and we'll see if they fit. Because if I can get them to fit, I'm going to call it close enough, moving on. And then I'll get on to 3D printing the plastic torsion bars because.
John, you made an interesting comment. You said you had a two-headed printer, but that you actually don't ever use the second head.
Yep.
Can you expound on that?
Just never have. Mainly because there's not that many fellows out there that use the two heads, and it's more hassle than it's worth. Unless you want to use the washable stuff.
I think his real question is, why did you buy it then?
It was a reasonable price at the time.
Okay, that's a good answer.
I actually would never ask John such a question. If you knew the extent of what he owns.
Yeah, well, yeah, that is true. I do have 4 kayaks ours, so hence each one has a purpose and a need. So.
And kilns? Do you have any kilns?
I have 2. One for glass, one for pottery. So yes.
And I've seen some of your stuff. It's quite stunning, John.
Back to the specialization pattern. At the time, I thought, hey, 2-head was reasonably priced. Got over at Micro Center.
It's okay if you've used them all at least once.
So,
You
yeah.
know,
But your practical experience is that you're just not ever work on things that require it.
Hey, I had a quick side question for Murray. Since you work a lot with Raspberry Pi and I2C, what is the maximum usable baud rate that you've been getting out of I2C?
I never modify the default, which I think is 400K or something like that. I can't remember, but I've never ever bothered modifying whatever is native to the Pi.
Okay, yeah, I experience a practical limit when I'm running with a microchip PIC, somewhere around 30K baud, and the default is much higher than that. So it must be my implementation where I run it.
Well, you've probably got a pretty busy bus. I've got about, I don't know, something on the order of about 10 to 15 I2C devices on one of my robots. And I was running full video and on a Pi 3B plus even. It wasn't even a Pi 4. And I didn't have any noticeable problems with, motor. Well, the motor encoders aren't on the bus. In any case, no, I haven't had any notable problems, but you're probably hitting the limit if you're doing everything over I2C, and you're, if you've got a whole bunch.
I'm not pushing it that much, just with single connection. I was using it earlier today with I told you about the Pi Zero that I fried this week by raking 12 volts across it accidentally. So I put in a new Pi Zero to test to run my Spiderway. And I was getting all sorts of errors on the I2C interface, and I went, "Why am I getting that?" I went, "Oh, I forgot. Since I installed the software on a new Pi, I didn't change the default baud rate."
I think what you might want to do is the one thing that you just clued me in on is that I love the Pi Zero. It's a great little board, but it is very slow. What I would do is consider swapping over to the Pi. What's it called? The 3A plus, which is I got one of those around here. It's this guy. It's that little square one. And this is a 4-core. So it's got 4 cores rather than 1. And I think it might only have a half a gig of memory like the Pi Zero. But the Pi Zero has only got 1 core. And if you're running Linux with that core, you're asking a lot of it. Whereas
no, I'm not pushing it. I mean, I'm only reading about, about 10 bytes 3 times a second.
Then you're not, then it's definitely your fault.
Okay. Well, what about on your interfaces? What's the length of your leads there? Maybe I've got capacitance that's causing a lot of errors.
Oh yeah, that could be, because I've noticed that before, and you've definitely got long leads in that Spider. The longest leads I've got would be in imperial units less than a foot.
But the I2C doesn't run all the way out to the leg. The I2C is actually I don't know if you can see this. Never mind. I've got a little stack of boards there that the leads between the, I guess maybe I got about 6 to 8 inches of leads between the Pi Zero and the boards.
Well, my guess is try it with a Pi A or a 3B plus, or try it with a faster Pi and see if that makes a difference first. Lead length could be, but some of the stuff I have noticed, for example, that if I put a I2C device up on a long, tall, like a mast, I have had on occasion problems, but now I've got about a foot-high mast with my IMU on the top. It's not a problem. So,
I assume the pull-up resistors on the Pi Zero and the Pi 3B are the same, but they're fairly weak.
yeah, yep. I don't add anything though. I'm just using the Pi I2C. The only thing that I'm doing maybe different than you is that I'm not adding all of the Pi I2C devices on the pins directly, because I'm using, I got one that I can hold up. I'm using these little breakout garden devices, and these I think actually have a little amplifier on the back. So if you've got weak signals, I think these amplified the signals.
Yeah.
Could be that.
Well, what's interesting is these are not random errors. It's always the most significant bit. So there's definitely a timing issue between going from address to first byte, I believe.
Sounds like your problem.
I know. Just looking for clues.
Yeah, I don't run into anything like that, frankly. I mean, I'm running roughly a dozen or more I2C devices on a Pi 3B plus, and I just haven't had any problems. So.
And the Pi provides the pull-ups, so you don't add pull-ups anywhere else, right?
No.
Okay.
Although, like I said, I'm using these Pimoroni things, which I think add a layer of amplification and isolation, because they've got a little chip on the back, and I'm pretty sure that because one of the times I ran a board like about a foot away, and I had a problem, but now I'm connecting it to one of these, and this thing I think is amplifying the signal quite well. So it might be something related to the ability to go a foot of wire or something like that. So I might be shielding myself from your problem simply by having these devices. But you might try just as a test, moving everything closer, keeping it under like 5 or 6 inches, and see if it makes any difference. I wouldn't think so, though. I2C is supposed to go up to like a meter or something like that.
Yeah,
it doesn't in practice, but.
Yeah, but I have seen a situation where on my PIC, if I have multiple interrupts going there, if I take up too much CPU on one of the interrupts, and that's a higher priority, it will cause the same kind of problem on the I2C interface.
Yeah. Sorry, I don't have anything else to add. That's about it. But
all right, that's all I needed. Thanks.
Hey, John, one thing you might want to look at is often that the I2C address is, it goes from 0 to 127, I believe, and it's only seven bits long. And but a lot of people, when they specify an address or censor, they'll use an 8-bit word, and it's just this. And what's making me think this is you maybe have running into this problem because you're saying it's your most significant bit that's getting you screwed up. So you might want to look at how the I2C address is being expressed, because you might be doing some with the 8-bit key and some with the 7-bit key. And that might be part of your problem, something you might want to look at.
Well, I can double check that, but on the microchip PIC, they do have an explicit setting for 7-bit or 8-bit addresses. And basically you take an 8-bit address and you shift it by 1 bit.
Right, exactly.
Feed it into the PIC.
Yeah, but what I'm saying is I have seen, we had a friend that was a club member for a long time, and he had just this horrendous problem because he couldn't wrap his head around the I2C address, how it was set up, because he would have parts that said this is the address, and it was an 8-bit address, and we would tell him no, it's a 7-bit address, like you say, and shifted, but he had a hard time getting his robot to work because of that problem. So yeah, I'm just saying is, somewhere in the code you might have just not shifted it, or anyway, just something to look at.
Yeah, well, these are just one of the perils of rolling your own solutions.
Yeah. Yeah.
Okay. Well, I have something I can show you all since I was surfing the web and found this. So let me click on something. Wrong window. So I assume you all are seeing this.
Yep.
Okay, good.
Smartphone robot.
So yeah, step 7 is where it was sort of interesting. But I'll slide up to the beginning because up at the very beginning, basically, is from how cheap of a robot you can build type thing. So if you look closely, it's mainly cardboard.
Huh.
Okay, so yeah, it starts off with building cardboard. There's 2 little motors. Okay, so up until step 7 is the basic cardboard robot. So there's where he's, and with some wires. So he has a wire sort of line going. And then he basically runs some wires out to his little remote control, and you can see it's just pressing, paper clips together to make contact. And then you throw in a little solar charger light thing. And then it starts updragging. Okay, so at this stage you get starting to updrag. And then you throw in little antennas to sort of set which motor is running. And then it gets to which caught my eye, the phone part. Okay, so he brings up the fact that the phone has lots of brains to there. So it can drive, has facial, voice command. So I just saw that this evening. So y'all might want to look at it because it was sort of interesting that it was using the phone. And in fact, that uses the phone to control the motors by. In one spot here, let's see, somewhere in here, he talks about basically using the screen to have it light or off on, so it control the motor effectively as sort of work. Where was that one line that I saw that caught my eye on that? Okay, you talk about speech, more come. I don't know. Okay, no, it was right before that. Yeah, right there where he's using the light values to basically run the circuits to turn the motor off and on by the screen just being white or black.
Yeah, there's an app that we've seen before that uses OpenCV that does that too. Essentially, it has 2 blocks on the bottom, and if the right block is white, then your robot has a sensor and just detects that white block and then turns to the right. If the other block is white, then it turns to the left. And the screen is basically the image that it sees. Yeah,
so
there's several Android apps that'll do that.
So this looks like it's an interesting article because I just saw it, so I haven't really. I scanned it real fast and I was like, but it lists around what the phone can give you basically, amongst other things.
Yeah, John, can you pull up a little bit on it? Can you go up? There's the MIT.
There we are.
App. I think it's called the App Inventor.
Right. Well, he said, yeah.
If you're not familiar with it, that's a lot of fun to play with. If you want to make your own Android apps very simply. It's that you can see it in that YouTube picture. It's kind of a what do they call it? Scratch type environment, but you make your whole app from that just using Scratch. So if you haven't used that, you might find that a lot of fun.
So yeah, this article looks very interesting. So I would say, hey guys, look at that. Okay, it looks like it's pretty well documented, well stepped through.
Mm-hmm.
Okay. So yeah. So I saw that, and then for Murray or whoever, if y'all are into CNC machines or that, I'll show you one other little spot I would recommend reading. Once I get to the other window. Okay. So. Okay. So, if you're wanting to know about CNC routers, cut and feeds, and everything else regard to software, in case you're like in Fusion or that, I would recommend this page because they do a very good job of detailed information on that whole steps, and they've upgraded their documentation since I got the original real CNC from them. So this is their current version out there that they have.
Is this the one, John, was this the one that was built in a wooden box or something?
Yeah, this is their new version. Yes, I got the original version. You're right. Oh,
this looks a lot less robust than the one you got.
Oh, this one actually is better in ways. Let me.
I can't believe that's got enough rigidity.
It's actually, yeah. I don't know if they have the original out here or not. Yeah, see, this is the one I have.
Yeah.
But yeah, they've improved it actually since then. They've upped their separate motors and stuff like that. But yeah, this is the one I have. But they have good documentation. But on the new documentation for their bigger one, it's even better documentation. So Murray, especially if you're into CNC or want to know anything about CNC, I would recommend looking here.
Yeah, I don't know squat, but I hear that Cincy name every time I go looking for these things.
Oh, it's
yeah.
Harold, you've already joined a cult. You can't have two.
There's cults of. I've got cults of cults, man. What are you talking about? I've got meta. I'm going meta with my cults.
But this one I got originally for basically $500. So okay, it's when they did it on Kickstarter and that. But they've been a very good company so far. I've been overall well impressed with it. And their documentation for it is extremely good. And this is their new version, and you can get it for around $1,000 to around $1,300 for a 30 by 30 table. So they've upped the size of it too. So it's like 30 by 30 by 4 inches depth.
John, can you put in a link for that?
Yeah, I'll do that. So yeah, this is, as I said, very good reference material, Mario. So let's see. Well, there was that, and then one other thing I'll show you since, I need to stop that. Let's see. Stop. Get to the other page now. And then there's this page. Now this one, who knows? But I just saw that tonight too, so you might click. So there's this thing. So it's a minimum CNC. So if you want to build one on a very cheap budget for a small one, there's this that you might want to look at.
So is this the CNC that you had used to build that robot you showed a minute ago?
No. But I'm just saying, this was interesting. That is the minimum cheap build one. So if you have a little drone out there, you could, in theory, build it. Now the guy trains that it really works, and it can make these small little gears and stuff. Speaking of building small gears and clutch type things, as a FYI thought, but
that's pretty funny because usually when the thing says it really works, you kind of have to like
wonder, yes,
ask yourself, do you trust that?
It should work. I can see where it could work. Okay, based on why.
Define your terms.
Yeah.
Yes.
It's like when they say it's really got dairy product in it. It's really butter. It's like, oh yeah.
But notice the price. I mean, it's around $40 versus the $1,000 plus.
I
So
think it's one of those get what you pay for, or maybe get what you didn't pay for.
Yeah, I think that's going a little too low bar on that one.
But I mean, well, yeah. But you look at some of the parts in there, it looks like it should work. I mean,
Yeah, but what
basic.
are you gonna do with it? I mean, that
Well,
might be. I doubt. I guess if you could make it a little,
oh yeah. Well, notice.
laser diode.
Well, yeah,
type thing.
right. Oh, and that's probably where I would go with it if I were doing it.
There's no rigidity at all, so I mean that one.
Yeah.
I would doubt you could even carve wood on that one.
Yeah, they have a little plastic there, it looks like. So, yeah. And they're using a drum for it. So,
Yeah,
And also, how long would it last? I mean, could you get through one project before you'd have to repair it?
yeah, but the price is cheap. So, it's a cost ratio at that stage, I would argue. So, yes.
Well, I like the water bottle weight. I mean, that way if you get thirsty in the middle of the job, you can just chug a few.
So anyway, so there was a little humor / it might work, cheap price. So but I would recommend reading the other one. Really, if you really are interested into CNC tool chain whatnot type thing.
Well, I got to admit I'm interested, but I'm looking for something that can give me about a 12 by 12.
Well, you can always up
and cut aluminum plate. That's what I want to be able to do. It's got to be rigid enough to cut aluminum plate.
Right, and looking at this, notice one of the design features, he doesn't have the head moving. It's the table that moves. The head only basically goes up and down.
Yeah.
So that's how you can get some of the accuracy, I suspect, based on that.
Mm-hmm.
And it also cuts down the cost a little bit.
Mm-hmm.
So, beyond that, I don't have anything else to add at this stage. So,
cool. All right. Nice finds, those. Always good to look at such things.
Yep.
All right. So, who's next? Who?
I can talk a little bit more since I was so rude before.
Well, did you get your tire taken care of?
Well, yes and no. I can drive it now to the shop so I can buy 4 new tires. So,
oh boy.
So it's kind of how that works.
Yeah, I was wondering how long it was going to take you to get that 3D printed in
for the car, yes.
If I had me a big, they call them big rep wraps. They're like a yard on a side and a yard tall. These things are massive. They've got 4 lead screws on every corner about that big around, man. They're not playing around.
Yeah.
You realize they actually have those now to build concrete houses.
Yeah.
So
I will tell you, I don't know if you have the opportunity. If you've never been to one of these things, I believe it's June 9th and 10th. I don't have a link on me. I see it in my email a few times. I'm not going to be able to go because, I'm a working man. So, not that, and I'm working in the office and I've got daily commitments for the next 11 weeks that I signed up on like a crazy person. So I can't go. But if you look for something called Design, the number 2 in Part, it's going on in Grapevine, and probably at the crazy hotel out there, right? I forget the name of the place. It's got a good
Gaylord?
Huge, yeah.
The Texan Gaylord.
Yeah. The Gaylord, yep. It's called Design, the number 2 in Part, and it is a manufacturing show. It's probably, and I see things free to come to the expo. If you've never been to one of these shows, take an afternoon and go. Take a little time off and go there, because it's designed for people that want to manufacture things and people to manufacture things for you. For instance, one of my most memorable things, I walked up to this guy and he has a bunch of little springs on this booth all over, and I go, you sell some springs, huh? Yeah, a few. And ask him, is there any spring you don't have? Doesn't matter. We'll make it to your specs. You just let us know what it is. That's what these people do. And they usually have a whole section of the cult. That'd be 3D printing for Murray there. A whole row of that going on. You see stuff for medical stuff. It's new stuff. They got a lot of robotics. I saw a robotic type manipulations going on. I saw a couple of machines that they still send me motor controllers on, picking and stacking so fast that the balls are almost flying off, but the precision is just right there doing stuff. If you've never been to the show, I suggest you go at least once and just be prepared to be overwhelmed with, oh, dude, I need all of this. You know, it's that kind of response that I had. For instance, I was 3D printing a bunch of stuff, and I couldn't find any good stuff to glue some stuff together. I happened to run across one of these booths. That's what they sell. They sell adhesives. And I said, well, I'm trying to stick 2 pieces of PLA and a few other things. Oh, here's what you know. Here's what you need right here. Here's some samples. Check it out. And if you like it, we got that by the 55-gallon drum if you need it. That sort of stuff. It's some high-end stuff, and it's really pretty cool things. Really pretty cool stuff.
So, can you get a link to that?
I just put one out there.
Yeah, Doug, thank you very much, Doug.
And it's free to register. Register for free.
Register, and you go through the aisles and stuff. And if you're not, I don't want to say impressed, but if you're not overwhelmed by about a couple of rows in, I will be shocked. Especially with this group and all the gadgets and gadgets and things like we like to poke at. I'm sorry, Murray, it's a little bit of a trip for you, and you're not going to be able to come to this one. But I can't solve everybody's problems, right?
Well, they have one in southern New England. Oh, that's New England, not England. Okay.
Yeah, they have them more than just here. They have them across the United States.
Yeah.
I don't know if there's international versions of this, but I know they have a bunch of them, and they're spread around a bunch of places.
I don't think Murray wants to be too close to all those cult members anyway.
No, well, it's just not cold. That's just one small section of it. It is growing than it was before, but it's somebody was talking earlier today in a whole other situation. They were talking scanning. You know, my idea a while ago was you set up a car wash, but it's not a car wash, it's a scan. So you scan your car, it gives you a quote for your insurance so you know what it is. And then when you wreck it or have damage, you get to go run it through there again and scan it again. So you get your adjusters and stuff out of the way, because hopefully you use a little AI and a little specs to see how it's supposed to be, and you do a quality enough scan. That was the idea. I did not know how hard that was going to be until I looked into it. And these people will have scanning devices there that will get down to hundreds of millimeters.
I thought he was going to say they could make a 3D printer copy of your car.
I bet you somebody will say they could do that. Whether they can or not, I don't know. Anyway, it's pretty cool. And thank you very much, Carl, for the nice compliments on my Rover running around. Thank you very much for that.
Well earned.
And I still got a ways to go, obviously, but I was pretty happy with that running around and doing so.
Harold, one of the things that I've noted in following the ExoMy chat and stuff like that is that given that it's all 3D printed and almost all the connections between the hardware are plastic on plastic or metal on plastic, it doesn't look like it's very durable. That the thing it rattles around a little bit. All those plastic on metal and metal on plastic connections seems to get loose or come apart pretty quickly.
Well, the most metal on plastic that I've seen are the bogies.
Yeah,
that's a M5 bolt that goes through there, and they've got no washers, nothing to hold things in place. It's going to just rattle all over the place. So here's what I did as a test, knowing that metal threads cut into plastic really, really well. I used what I had laying around. I put the bolt head, washer, bogie, washers back to back. Because washers have two sides to them, right? You got because they're punched through. So I put the two smooth sides together on it. Then the bogie bearing. Then another washer on the outside of the bogie bearing with a lock nut on it, right? So it holds it fairly securely, and I could tighten down the lock nut so that it still moves freely, but I've got pretty good rotation. To keep the threads from just trashing the plastic from the first time going through, I had me some Teflon tape, plumber's tape, and I wrapped it around that thread, around that bolt, really good. So it kind of dulls the threads a bit and makes it a little bit more slick. And that's when I put the bolt through the whole thing. So hopefully we cut down on some of that wear and tear. I have no idea how long it's going to last though.
Well, Harold, I think my point would be that if I was to ever consider building something like that, I would really want to re-engineer some of those design decisions to have actual bearings and actual bolt through, and not rely on the plastic for so much. Because to me, the 3D printed plastic just is not that strong in so many of the places on that design.
You're right, and there are concerns. I have probably most of the same concerns you do. I would think with what we got going on and having to build one, or knowing about the sizes of, let's say, what do they call them? Not shaft things, thrust bearings, I think is what you're going to be talking about, something along those lines. Knowing about that, and in order to make that hole big enough to get a nice thrust bearing in there, so you can put that M5 through there, which I do believe you need. Yeah. You're going to need a little bit bigger 3D printed part to stick that in. In this case, you just don't have enough. You just don't have enough diameter to put one of those thrust bearings in there anywhere close, and then be able to then have it. If you went with an M2 bolt, you might get a thrust bearing in there, but then you're going to snap the thing off as soon as you go do anything. So that's not going to do you any good. I think the M5 is a given. At least that gauge of metal for what weight you have going on, and that's just me rule of thumbing it and knowing how heavy things are and that kind of stuff. I could be completely off though.
Well, I tend to over engineer things. Like I built a bed back in the 80s that was strong enough to probably hold 20 people, although it never happened, by the way. But like these things, like from Servo City, use a 1/4 inch shaft, which is in stainless, extremely strong and way more than you'd ever need. And I'm probably going to end up with something like this on if I ever actually go to the trouble of spending like $3,000. I'll probably end up building stuff with 1/4 inch shafts just because I don't have to think about it.
Well, the 1/4 inch shaft is really, really close to the 5 mils. So, and I like that coupling kind of design. And there may be a way with that coupling looking there to replace the bogey bearings with those things that you're just holding up, and make it not too difficult to deal with. But you got to have to figure out how to route your servo connections. But that's an easier problem, I think.
Well, for all the talk about how weak plastic is, the motor that I destroyed earlier, you would have thought, oh, I got to take this call. Sorry.
Okay.
Okay, next.
Yeah. Anyway, but I don't have. Can I show a little bit? Yeah, I did on my last stream. I did something. I did get the head mounted with some stuff in my pan and tilt on there. This is just extra video cable. So I've got the pan and tilt going. The tiny LiDAR to come in is going to fit right there in there. And I do not know how well this is going to work, but again, I think I said this a bunch, but I 3D modeled this thing up so it just clip right in and be solid and pop right in there. And then use the standoffs to cut their own threads. And then the tiny LiDAR is going to be right next, because I don't need to be really precise or kind of precise. I don't need to be all that precise, just I need to be close. So I'm guessing, we'll see how close I come, that the center of the camera and where the LiDAR is going to be showing are going to be close to the big thing that's either in my way or the cone that I'm looking for. I'm not, because the cone's 17 inches tall by however many wide. I'm not looking for millimeter things. I'm looking for, a couple of inches of things and bigger, right? And larger with the slope, depending on what I'm looking for. I think that this will give it to me at least there. And then when I need better, I'll make better.
I would think you could angle them to point them towards this like you could set the optimum area where they're aligned, right?
Yeah,
So,
I got you. So I
uh,
put a target out about what, 3 feet, 4 feet, or some arbitrary distance that seems good, and make sure the center of those things, because I can shim. I know I can shim these standoffs
right.
for doing angles and things to make that happen. I know
The
I can
center.
do that.
Yeah. How did you find that pan tilt? Because that looks like is that the $10 one off of so many places, eBay? Now, the one I saw that a few years ago was really sloppy, and I don't know if it's because of the way I built it or if it was made that way.
Well, this I believe is from. I think I got that from the robot store or something. I think it's an Actobotics thing.
But the thing is that like this, the one servo. So for pan, it has the weight of the servo on top of the servo head, right?
Yeah. Yes.
So the servo head itself has to be pretty secure, and what I found was that it like the axis, yeah, that axis right there, it wobbled a lot.
It does have some wobble on it.
Yeah.
I may have to, as Murray says, design my own and over engineer my own eventually. But I had it laying around. I bought it a long time ago. We're going to use it until
Yeah.
I figure out I can't use it. So,
Hey, well, if you get stuck, let me know, because I found a metal one that I purchased that it's better balanced because it doesn't require, like, it only has the weight of one servo lifted. It doesn't, like this one, have the weight of two servos lifted. So if you want another design, I can dig that out and send it to you. It'd be easy to print up for these smaller servos if you want.
yeah, I'll take that. I'll take that recommendation.
Okay, let me see if I can't find it.
We're going to play with it. Like, I work with a lot of people, very, very, very smart people, and where they get caught up a lot of times is the old phrase comes out: perfect is the enemy of getting anything done.
Right.
And I have been in that mode for a very long time, and my mode is now, if I've got it, I can strap it on there, I can make it work. But it won't work because I know it can't.
Yep.
And when I say I know it can't, I'm a big fan of failing fast.
Yep.
So I want to do the effort it needs to make it work, but not go extraordinary effort or superhuman effort to make it work. Because I've done that with a lot of other projects. I've just bailed and done something else because I'm like, yeah, I can make that work if I spend the next 30 days on it at 8 hours a day. And I had all these other tools and perfected it up. And is it going to do any more better than me going over here and just flipping this bit over here and being done? And the answer usually comes out to it's good enough for government work. It's not, it's good enough. And good enough by definition is good enough. And when I need to be more precise, I'll become more precise. In fact, that tiny LiDAR, I was looking and researching those things, and they've got a cool board that takes 3 tiny LiDARs on them at 120-degree angles, so you can do get the angles right to do triangulation with your 3 LiDARs on there. And that's pretty cool too. And I've got a feeling that's going to be in my future at some point. But I've got to see how the base stuff works first. Kind of how I'm rolling. I'm about to spend a bunch of money on some tires.
Nicely done.
Yeah, and I would like to say again, thanks for everybody, and thanks for all the support, and thanks for all the information that everybody's given me, whether you knew you were giving it to me or not. This thing on Tuesday nights, I know improving. I'm back at the office full time now, and for a couple of different reasons. None of which is because I absolutely want to, but I volunteered for some things that I think it's important enough for me to be there. Saying that, they're talking about opening up the training rooms again for user groups in the evening. For this group, it's not exactly the most ideal. One, because of placement, and two, because of capabilities of running robots into walls and mechanical things and all the other stuff that this group would need. But saying all that, I'm going to parrot, I believe, Mr. Anderson, and say that I really like these Tuesday nights. I really like the virtual on the Tuesday night. You know, that's a decision we get to make as a group. But I'm putting my vote in with Anderson, so I say we keep these Tuesday nights virtuals, and the second Saturday, that's when we go down to the makerspace and hang out and lie about how big a fish we caught, or however that works for robots. You know, I mean, that'd be my thing.
Well, right now, tonight, they're having wood carving. The guy used to do it on Wednesdays, to give you an idea.
Okay.
He typically has around 4 to 5 people. Okay. Now, if you look on their calendar, you'll see on Saturday they have some type of old computer thing going on, and there they tend to have more people in that room, in the front room. So they vary in sizes of number of people in the room. So right now, though, yes, I know that they have to wear masks. So that's the good aspect of it. And as for size of number of people, as I said, it seems to vary. They don't really have any size limit, as far as I can tell.
Yeah, for me, it isn't truly the number of people on there. For me, it's the availability of all my stuff and not having to load it in and load it out and be productive. And when we're talking on this, that's what it comes down for me.
Well, it's trade-offs. I agree.
I don't really care about the number of people. I know we're going to have some limit somewhere, but that's not really.
Well, I don't think we have to worry about that as much, the number of limit of people, because, and especially if we're doing a hybrid version, okay, which is where I think we really should be going to. But there are times when you're actually seeing a person direct. You know, virtual seems to work pretty good for the most part, but there are limits to it too.
What do you mean by hybrid, John? Can you expound on?
Effectively, I would do it like every other week type thing or something. I wouldn't necessarily do it absolute one or the other. In other words, I would do it sort of, or else have a virtual robot there type thing. Even though, yeah, it has its trade-offs too.
Oh, that's nice.
Is David's talk this weekend, David?
June 12th.
It'll be, yeah, the weekend, 2 weekends, 3 weekends from now.
Okay.
I think.
Hey, Carl, that is nice. That pan and tilt is really nice, and it's using some heavier servos too, so it can really sling the weight around a little bit more if you want to do that. And just from the initial glance, yeah, it'll fit right on top of this. I might have to print some kind of design up an interface thing so it'll screw down into holes and that kind of stuff to make that fit, you know. But I think
I purchased one of these. I haven't assembled and tried it yet, but what's nice is that if you get it on the Metal Gear servo, you can see it's got a hard mount from the servo shaft to the bottom bracket, and then that gives the pan orientation for the tilt mechanism, and then the tilt bracket holds the tilt servo. But the tilt servo, the way it's machined, it rotates. Obviously, it rotates the tilt bracket on one side, but it actually supports the other side of the tilt bracket with a little ball bearing. So
yeah, I was looking at the bearings and things, and that looks kind of nice.
It's a really robust design. I haven't seen it in the smaller micro servo like you have on your model right now, but all I know is that I started looking for this when I started off. After I started off with the pan tilt that you have, that style, it was so wobbly that I couldn't use it. I mean, I'd have to move the robot, let it sit for quite a while before it was almost stable enough that I could use the image.
Yeah, you can take a picture of it and have it blurry and stuff. Yeah.
Yeah, it was just unusable.
Now
David's going to show us the right way to do it.
Well, no, it was just your suggestion.
Yeah.
It reminded me. I don't know if you can actually even see this. But basically the tilt pan mechanism is down here and the camera's up here because I wanted it to be up high in order to look down. And so and these are big Metal Gear servos. Can you see that? Not really.
Yeah,
This whole unit sits on top of that one. And there's an arrow shaft here with a ball bearing in it at this intermediate stage. So that prevents any slop or
You're right.
in this direction.
Yep.
And then this here, I don't know if you can see this rod, the other axis is actually driven by this push rod.
Yeah.
got it.
So that way you keep all the rate down below, and yeah,
And
I
all
like
the
that
electronic
design
noise away from the
head.
from
Yeah.
the IMU, yeah.
You got all the good
But that's
features in that one.
basically the same idea, which is to have a ball bearing on the other side of the
That is one of my concerns, because the way my head is situated up, back behind that's where the GPS and the IMU is going to go, and I've got no doubt that I'm going to get some interference on that, and we'll just see how much I can deal with it or not. What now?
Yeah, I guess I
can't
like that
hold this up
design
to right
because you could 3D print that easily and not have to use metal slash to cut and that. So makes
No,
moving the rate
I'm
off.
just thinking with all the servo signals and stuff going
Oh,
in
that too.
and all the I2C, that's what I think is going to be
Oh
effective.
yeah, well that would be a plus too.
Yeah.
But basically, that's a pretty cool design you had there, David, because I mean, you must not have any vertical wobble by the way that it's got such a big distance from the upper support and the lower mount. So it can't have any more vertical wobble than the rest of the mast.
And that mast is a carbon fiber mast that's bolted to the chassis.
It no give, huh?
So I can pick the robot up by.
Why am I not surprised?
I will tell you what happens in the real world when you have a robot that can run around in the Colorado Rockies is that from time to time you fall off of a steep place and you tumble end over end, and so that tower has got to be robust enough to support the robot when it's upside down. It happens. As a matter of fact, I've got a video somewhere. A robot's driving along a steep path and it fell over the side of the path, and it like tumbled end over end like 3 times and landed on its feet. But it's got an IMU. It still knew where it was. It just picked up where it landed and kept going.
Oh, that's awesome. And the shaft didn't break off.
David, don't let the U.S. military get a hold of your robot.
Well, there's a true story. About 15 years ago, a major contractor called me up. They'd seen my webpage and they'd said, "Well, you got what we need. Let's get together and talk." And I talked to him about it a little bit, and maybe it was a mistake, but basically my decision at the time was that this was not center to my life, and getting involved with these guys would make it so. So one of those opportunities missed.
Yeah, well, I've had a few people in my life who've made it very clear that as engineers, we should take responsibility for the things we develop. And I don't know that I'd want that responsibility in that case myself.
Well, that's a good point. I was just too lazy.
Well, you chose life, right, over work. Who's going to argue with that? That's good.
Well, and the way I do robots, I can just do whatever the hell I want. If I decide I don't want to do something, I don't do it. If I decide I want to, try to make the robot go sideways while pirouetting, which is useless but interesting, once you start like making a significant portion of your living at it, you don't get to make that part of the call anymore.
No, someone else does the requirements and the fun goes away.
Yeah.
And then the schedule and the calendar comes up too. So, yeah.
But the things they have now are light years beyond that. If you follow any of that, Asimov's 3 rules of robotics, the very first robots broke those rules. The very first robots were the cruise missiles. They broke all 3 rules.
I don't know how many people have been following, but if you do like Google image searches and stuff like that, there's all these EU robotic competitions. Well, they're also in the US as well, and like they're university teams and company teams, and they're making all these sort of 6-wheel Mars rover style things with obviously 10 or I don't even know what their budgets must be, $50,000 easily, but they're making beautiful hand machined 6-wheel robots with full engineering teams of like like there's one from like I think Romania, which a whole bunch of English speaking Romanians students all talking about their particular team's contribution to the robot. And it's like,
God bless them. God bless them.
Yeah,
Harold,
exactly.
I have a question. Watching your robot run around, and maybe this is beyond where you are interested in going, but watching it run around, it seems top heavy. And as I look at it, it doesn't seem like it's the weight distribution. It looks like it's not wide enough, that the body's not wide enough.
I think you're right. I think you're right on it. Yeah, I think it's a little narrow for a couple of reasons. One, getting my fat, meaty hands down into the guts of it to mess with it. And two, when it gets a little bit kilted, as you've seen in the video, it's just a couple of moments away. And what I mean by moment, I'm talking about statics and dynamics moments, not an effort at time, right? It's just a little bit of a moment or two away from just toppling and going away. I think the only reason it didn't topple that way in any of that video was that the bogies aren't constrained enough. And if I could have constrained the bogey, I might have kept it upright a little bit better. But then when the bogies gave way, at least the back one gave way, it stopped it all from doing and moving over. And that's what I saw in the thing. So,
is there any way with the design you have of widening it, split it in half and stick 3 inches in the middle?
I don't know.
It's another few days of printing.
Yeah. Well, one of the things we could do, I think, maybe we don't split the body, but we expand the wheelbase a little bit.
That would be the same.
All right. No. If I think about it, I think you're right. Wait a minute. Let me think about this.
Well, Harold, if you think about it, Harold, the bogies aren't connected to each other on that design. And so you could simply just print the body wider.
Well, no, the rear bogey matters because it's the total width. We'd have to redesign that one. Here I can show you. Yeah, I can show you. See, we got one bogey here, right? You got a rear bogey here. You see, it's the total width.
Yeah, the rear bogey has to have the wheelbase of the rest of the bogies.
Yeah, so this would need to be redesigned and reprinted. And I'm thinking that you guys are not wrong, and I'm thinking out of my head, this chassis here is a real easy print. Now I've got some wacky Z thing going on here, but this chassis here is a real easy print. And if me and my lack of Fusion 360 skills can't do a little split here and add about 1.5 to 2 inches on each side of that and expand that out and make that happen and then reprint it, I should just stop doing any of this now. I mean,
it looks like you'll still have.
Head.
It looks like you'd still have plenty of ground clearance.
Yeah.
Because of the length of the bogies, but it might be a lot more stable if it was a little wider.
You may be right about that. So I'm going to keep that in my back pocket, and I think that's something that needs to happen. I would like to get things working and rolling around on its own, and then I'll worry about it being extra stable.
Okay, well, that brings me to my last topic, which was, because last week you were actually able to drive your robot around, and we gave you a gold star to put on your forehead.
Yes.
That I can turn mine on. So I want to propose, I think we need something official, like a nice wooden plaque with gold bars on it, and we keep track of every week who could turn their robot on. And, that we have a formal, maybe even a ceremony with music and everything. And and we say, well, you know, over the last 3 months, you know, Chris turned his robot on 4 times. David turned no robots on, and so forth. I just think it ought to be a thing.
There's a streamer out there. I know most of you don't check Twitch very often, but there's a streamer out there called Oh Bother, like poo, oh bother, and he's got some salty language, and he makes things in his garage as well. But one of his shticks is he has this 4x8 piece of plywood in his garage, and if you subscribe through Patreon or some other kind of thing, he will burn your name into that piece of plywood. So if somebody had a laser printer or laser etcher cutter or whatever and had this, we could do something roboticized of this. And
this is good. This is excellent.
I don't have one of those things, or I would volunteer to try to set that up. But
well,
cool.
This is a creative bunch of people sitting around here. Surely we could come up with something appropriate.
David, the only problem with this is that there's those of us who've actually had a robot that could move around, but we've backslid.
Aha. Well, that's what this process would uncover.
Yeah, exactly.
Well,
I'm sad that I'm no longer able to have a functioning robot. Yeah.
well, so okay, so in the wall of fame or shame, however we want to describe it, it could be a website page, right? And in the one column, there could be the list of videos, people who've turned them on. And then the other column is rest in peace or back to the shop for a while.
But Carl, I don't know if I want to be publicly shamed every week.
No, I don't want to shame people who can't turn on. I want to glorify the people who can.
Yeah.
And if it could be done in gold leaf, that would be good.
Gold leaf.
We can probably find the CSS color that's closest to gold leaf.
We can have T-shirts. How about T-shirts? I can turn mine on.
Okay.
All right,
that sounds a little bit too close to something else, David. I'm not sure you can wear that in public.
Well, you know, it would have a slightly naughty connotation to it that would make it popular with the kids.
It powered up again, huh? Okay.
With a little Viagra logo.
Okay, well, is there something like, okay, I'm sitting in front of this screen with all these little squares on it with people's faces. Can I put a stamp on one of them or on each one of them? A gold sticker.
Don't know they have that on those. No.
I don't know. At one time, Carl had a robot dancing on his head.
You can have the background changed, but you have to have the person.
Well, I don't know how centralized, aside from Google, could overlay image data on each participant. I know how you to whoever reminded me of the Snapchat filter. Yeah, each of us could do that individually.
Right.
But I don't know how we as the organizers could.
That's no good because people might lie.
Yeah. Yeah, the organizers never lie. But okay.
I am not a cat. I am not a cat. I'll tell you
so
that.
You can use this background only if you've got your robot moving.
I am not a cat. Are you talking about that video of the lawyer who?
I am not a cat.
Yeah.
Oh yeah, in front of the judge, right? Yeah. That was
there's a worse one out there. A guy goes in front of a judge and he goes, "Are you really? That's your name? You're going to come in front of me with?" And the judge just called him out on it. He goes, "I don't know what you're talking about, Judge. My name is so and so and so and so." His tagline down there was BF, and you can figure out what the butt and the F was. 3,000.
Okay, so back to off the subject. Harold, you were saying you went to enlarge the thing or that, or
I
make
think
it smaller?
I'm not going to. I'm going to work on all the software and stuff because all of the stuff that needs to go, and what I can do in the background, and because all of this stuff will fit, I want to, as Murray has rightly pointed out, do something about the bogey bearings. The bogey, the actual thing that goes through the bogies themselves are fine, but the plastic bits in the bogey bearing are going to wear crazy. So why don't I look at redesigning those and at the same time increasing my space, because I think I can slice and dice that thing, move the sides out a little bit, then fill in the space with a couple of extrusions and join it all back together
Okay.
and reprint the thing.
So there's a thing called NetFast Studio that
Oh,
is
yeah.
nice. So if you don't know about that program, you might want to look at it because you can do cuts, you can enlarge it,
Yep.
and all that angle. So
I've used it slightly. I usually use the Mesh Lab or Net Mesh or Mesh something
right.
or other. It's,
So,
yeah.
so if
same-
I want to like cut this in half, I can. So this is how you can make bigger parts out if your bed is not a certain size.
Well, luckily for us, Max and Miro have provided us with step files for all of these things, and those are readily importable into Fusion 360 and other programs.
Good.
So they're real 3D models that I get to manipulate, as opposed to like most people just give you the STLs, which are just a mesh, and then you have to use tools just like you just described
Right.
to even have a chance of doing stuff.
Well,
So
Harold,
that's good.
Harold, one of
Harold,
the
it's
things
that it's that
Oh, go ahead.
rear link. Yeah, other than the fuselage itself, it's really the rear link is the only piece that has to be re-engineered. Is that right?
Yeah, the rear link needs to just be extended, and that's easy enough to slice it, extend it, and then add, literally add an inch and a half or 2 inches on each side of that thing, and just literally I cut it, I move pieces apart, and then I extend one face to the other and tell it to join everything up, and I think that's done.
Harold, one of the things that occurs to me is that the ExoMai is kind of like a beta test. It's never really been, it's a new community and a new robot. And it occurs to me that maybe to propose to that community sort of the idea that there's a set of modifications that can be made and the step files can be made available to improve over time this design. So maybe a year from now, the step files that are the default for someone to download for an ExoMai incorporate some of the expertise of this group, which is kind of, and you can advertise it even.
I can see that happening. Yeah, I can see that happening.
I think they even encourage that.
Oh, absolutely. Yeah. I will guarantee you, the way I feel, because it's on GitHub, if we as a community around these guys, because I know, Murray, you're on that Discord too, and there's probably half a dozen active people doing it, maybe a few more at times. I think if we get if any one of us submits a PR to it, Max and Miro will be ecstatic. Somebody helped us, and I think they'll be ecstatic. And I don't know how far I'm going to go with this. I know my goal is to see if I can compete in the contest. And then if I keep going, I keep going. And if I don't, I don't. Even if I don't, I'm going to have a neat thing to be able to show off and exhibit whenever we get live again and have kids drive it around and do all that kind of stuff.
Well, Harold, like it or not, probably most people would like it. That Discord channel for their ExoMai has almost 250 people signed up to that.
Really?
And they haven't done a lot of advertising. So there's a lot of interest in people building that ExoMai. I don't know how many people among the 250 have built one, but it obviously got a huge amount of sort of press in the robotics world, the hobby robotics world. And if it can be demonstrated that that robot is viable, I'm sure that somebody might even consider start manufacturing the plastic kits, because it's frankly a very good introduction with the addition of some sensors and things like that we've identified. It could be a very good introduction to robotics for schools or hobbyists or anybody.
I will tell you, I know you guys have seen me struggle in a lot of ways to get my own custom built thing working, and in just a few weeks I've got something that runs around. I think that's a testament to some of the design and some of the straightforwardness of it, even though some of the documentation is a little bit lacking. But if you've built anything at all with a screwdriver and a few other things, you can figure it out, right? It's not rocket science, so to speak.
Left as an exercise to the reader.
Yeah, something like that, exactly. But no, I'd even considered that if we figured out a couple things after I built one or two of these things, if I had a printer just laying around doing nothing, if somebody wanted a set of parts, if they would pay me the plastic and a little bit for electricity and cover the shipping, I'll print you a set of parts. on the thing. But the thing, before I offer that though, I need to get one built and look at it, because the the bogey bearings are coming. See, that's a central thing. Those things need to be fixed, because those will probably be all right for what I need to do. But if you have pretty much any wear and tear on them, they're going to just die. They're going to die a horrible death. And so we need
Harold,
to.
it's a generous offer, but if 250 people in that ExoMy channel all of a sudden contacted you and said, "Please, I'll send you the money," I don't think you'd.
That's okay. That would be okay too. I would put them on a waiting list and tell you I'll send it to you in a couple of years. I'm not going to kill myself. And you're right, Murray. Y'all 250 of them sending me things at one time, it'll just overwhelm me. And I'm like, okay, first come, first serve. And it'll set out there in escrow until whatever, and I'll print it, but it's going to be a couple of years before you get your parts, if that's okay.
At that stage, what you'll do is you'll point them to that page I show you where you build that CNC, and you'll get one of the $30 hot end spitter guns things that you can get.
Yeah.
Or actually, I think in the presentation, was it Mira or Max? One of them said that if it could be demonstrated that there was sufficient interest, he was already thinking of how to get a more of a volume manufacturer.
I mean, because if you think about it, if you're going to start making anything at all like that, maybe you invest in some injection molded things. I don't know what the cost and what the thing for setup is, but like Murray said, if you got 250 people that want these, maybe that warrants a cost, because there's some custom injection molded stuff that'll get you stuff in a few weeks or a few days. I've seen a couple of those things out there that they literally have the mold they make, and of course it destroys it after you make the mold. But there's people that will prototype use some injection molded stuff, and maybe that's cost enough if you want to pay for it to get you some of that. I don't know. I would imagine that design the part thing I was just making, I bet you there's somebody there that knows about how to do that. Yeah. If you wanted somebody to ask, I won't be there to ask. But.
Low volume soft tools.
What now?
Low volume soft tools.
Low volume soft tools?
Yeah, so meaning that they're relatively cheap and easy to make, but they only make dozens or hundreds of parts, versus the high volume hard tools, which is what you'll have to make like mobile phones, where they chug out 100,000, 200,000 before they wear out.
Yeah. So again, I don't know what the cost is on that. I'm sure it's more expensive or whatever, but
you'll be amazed. So it's gotten cheaper, like most things. They're like the 3D printers in that regard. So yeah, I don't know the price offhand either, but yeah, you can do injection plastic, and that would be the route to go at that stage.
And just another comment on the ExoMy, and that is that someone, I think David, you suggested a mug for those guys. So we want to thank you for that suggestion, and thank Doug, who today got an order submitted. So we're going to have mugs sent directly to Miro and Max in Germany and Switzerland. Good. DPRG mugs. Yep.
Yeah. Awesome.
Yeah.
Then all the teenagers in Germany will want one.
There's our demand right there.
I'll tell you, the thing in their presentation that shocked me was the fact that neither one of them currently owns one of these. It just doesn't suggest that they're really that forward looking.
It just means that they don't have a 3D printer. Is what it means to me.
Or that they were enjoying the ESA budget and didn't want to go beyond that, because why should they? It's paid for.
I think they're two very busy young men who are just starting a career and have new big fancy jobs for the first time in their life, and they're getting paid well, and they're like 40 hours or 60 hours and working hard, and they don't have time for a hobby right now. Maybe they have partners or who knows what. But
you mean single young men in their 20s and 30s with disposable income?
Yeah. I seem to remember that at some point in my life. Yeah.
And with a single young man with disposable income, and they might on occasion may go someplace and look for a significant other, at least for the evening. Who knows, right? So they have other probably other priorities. So Exactly.
Cool.
I just
right.
bought a crap ton of tires.
So how bad are tire prices nowadays? Because I
Well,
suspect like everything else, it's gone up.
it's not terrible. I've got a 60,000. I got a set of tires, 4 of them. Balance to put on, all that kind of stuff, and an appointment to show up tomorrow at 2:00 at the National Discount Tire. 60,000 mile warranty on them. Decent tire from all of the reviews I can read. It's coming in about $525
That's not bad though.
tax title and license. It's not terrible. It's just like, I just didn't need to spend $525 on tires right now.
The last time I got a tire, it was around $600, $700.
Yeah.
It was at discount tires, but yeah.
Well,
Well, guys,
it's a van.
I'm gonna head out.
Okay.
We'll see you, Dave.
Good night, Dave.
This is on a van, so we're talking here. They're 15-inch tires, no big deal.
Right.
My truck's a different story. I go put sets of tires on them, and we're talking $150, $200 a tire easy,
Oh yeah.
just because of size difference.
I know this is way off topic, but it's kind of related to robotics only peripherally. And I just read an article about how in the US, Ford sells 900,000 F-150 pickups every year, which outsells all other cars in the US by any manufacturer collectively. And this new electric version of their pickup that they're putting out now weighs 6,600 pounds. And that it's I think as heavy as a Humvee, and that it will go 0 to I think 60 in 4.4 seconds at 6,600 pounds, making it by far the most deadly vehicle on the road.
Oh yeah.
Yeah, in
Probably.
collision,
Well-
it definitely wins.
That's only if you're not in the F-150. If you're in the F-150, you should be in good shape.
Oh yeah. They basically said that if it hits any other vehicle, it will destroy that other vehicle.
Yeah.
It's got
Yeah,
low, all the weight is low. It's got, I think the battery alone weighs 1,800 pounds.
Yeah.
And if that hits anything on the road, they're dead.
Well, I'll tell you what happened with radio controlled cars was when the first electric cars came in, they weren't very quick and they were expensive. And so if you went out and raced against the nitro cars, you probably weren't going to do very well and you were having to pay more money to do it. But as the technology evolved, it only took a short amount of time before the electric cars were significantly faster than the gasoline cars and cheaper. And then once that happened, the asymptote, zam,
Yeah.
So that's what we need here. We need a car and not an F-150 for what do they want? $70,000.
No. They're actually $4,000 more than the gas ones.
So we need one that's faster than the gas ones and cheaper. When you hit that magic point, then you won't have to talk anybody into it.
Well, the article I read, which was I think in like the New York Times or something like that, was pointing out that this thing is only 4,000 more, and obviously would have a much lower repair costs over its life, and a lot fewer moving parts, and
gentlemen, I'm sure we'll live to see the point where we'll reflect back at how incredibly complicated those gasoline engines were.
Well, actually, the last thing I read was they were projecting that the average electric vehicle cost will drop below the average combustion vehicle cost by next year.
By next year.
The average.
So that's that magic point.
Average.
It's got to be cheaper. And there's no reason for it not to be.
No.
I was reading an article that said 5 years, but okay, news about being sooner than that.
And we'll have totally autonomous robots that are equivalent of humans in just 10 years. That's been 10 years away.
I read that
all
on the
my
internet.
life. It's been 10 years away all my life.
A lot of things can change, but the primary reason for the cost dropping quickly is the per unit. The largest cost of the electric vehicle is the battery, the batteries, and as production goes up, the per unit cost comes down, so the price is dropping fairly quickly on electric vehicles as more hit the road.
And we still may not have arrived at where we're going to end up in terms of battery technology. That's all changing so fast. And, we may very well find ourselves with cars that charge in 10 minutes and can go 1,000 miles. You know?
You should read up on the technology behind the Tesla, the electric motor in their Tesla vehicle. That's pretty interesting. The technology that they have developed there. It has a lot to do with with how they position the permanent magnets in the motor's armature to reduce eddy currents and increase the efficiency of the motor. It's pretty interesting.
Gentlemen, I think I'm done.
Yeah,
Yeah,
I think so.
Unless, John, did you have something to say?
Who, me?
Mike, oh, you're talking about who?
Joshi.
No, not me. You.
I agree with the idea of roll calling. Guys.
And unfortunately, I can't
So,
find it, but
yeah,
maybe next
if
week.
I can turn it on and announce.
Next week, hopefully, I'll find it. But there's an article I saw that there's a car that's going to be out there in a year or two that will do 1,000 miles solar charge type thing. It's the 3-wheel light one that they had a couple years back. They've rechanged it basically to have batteries in it, so it's not as heavy.
Carl, here's an idea. Many years ago, when I led a DPRG contest, went out and I bought these. They're from Party Favors that were like at the Target store. Huh?
Yeah, baby.
All right.
Huh?
All right. But
And they could say,
virtually, I mean,
I turned mine on. What do you think?
well, nice. But now, I mean, do we mail those out? Do we force people to wear them?
We force people to wear them. We force people to wear them.
You cannot say anything unless you put your badge on. Nobody would ever fire up the robot.
Well, the other option was just, a gold star to stick on your forehead.
Yeah.
David, the fact that you were able to pull that up so quickly from your vast storehouse behind you, I don't know how you did that.
I was impressed myself at how quickly I found it. All right.
Let's keep chewing on that. We'll figure out a way to do it. Good night, everybody. Have a good week.
Good night.